the bitrate like failed, so I couldn't really open the pop because I reopened it. I had to restart the stream. It looks like the bitrate is failing again. I'm gonna leave it this time. I have another pop in the freezer, but I want to open a warm pop / soda, whatever you want to call it. Anyways, another tick to the countdown, or the count up, whatever direction this countdown is going in. It's all about perspective. But there is an end to the journey when it's complete. So I'm like writing a JavaScript engine, but I don't know. You can't get precise timing on the modern operating system. So there's a get system time precises file time. That's the only file time that seems to be accurate. It's like 10 to 15 millisecond accuracy, which is horrible. I'm trying to time some assembly language. If I run a really big loop, I'm not even timing the code. I'll end up timing the test scheduling, the context switches, when the CPU's running boost mode or whatever, it's not even going to end up timing the time of the assembly, whatever. But then there's a CPU cycle timestamp, and that has higher accuracy, but it's not related to time itself. It's just an internal counter of the cycle counts, clocks, whatever you want to call them. Chew! I gotta sneeze. Maybe I just sneezed. I feel so much better now. Look, I'm dying. Anyways, I really hate Windows. Can this magnifier tool just not work? If I like plot out, gets us some time, whatever. You see how the plots are bigger between them? That's because it's like 15-second, whatever, 15 millisecond timing accuracy. It's not very high, but it's real time at least. CPU cycle timestamp. You see how the ticks are closer? That's because it's more accurate. Not accurate. It has more precision. There's more uniquely identifiable points as time goes on, whatever. More than there is with get system time. Except this isn't a real time. It's just the CPU clock cycles. So I'm going to get the CPU cycle start, and then I'm going to call file time start to get the file time. Precise as file time. And I'm going to call CPU cycle end to get the CPU cycle timestamp before and after I get the system precise as file time. So I can subtract CPU cycle timestamp from the other CPU cycle timestamp. Somewhere in between here is going to be the time around when the file time get precise whatever file time started. So how accurate is that? It depends on how accurate the CPU time is from Windows, which sucks. But at least then I'll have some kind of like point between the two and how it relates to real time itself. I'm going to do that after I run the benchmark between. So I'll run the benchmark. After the benchmark, I'll do this again. I'll get the CPU timestamp, then I'll call system time, precise file time, then I'll call CPU timestamp, and then I'll subtract the CPU cycles here and here, divided by 2, and somewhere in between there is when the get system time is called. So like it's not going to match up exactly, it'll be close enough. Like 50-50 are like the best odds in this case. So somehow I could possibly make up like a fake time. Just, I don't know, like artificial time. But I don't think it would be accurate. So I'm probably gonna have to keep the system time separate from the timestamp, because timestamp isn't even relative to real time. And then whichever instructions are faster, I don't know. I still gotta think about it, but I think this is the best way so far to like benchmark assembly language. And I haven't Googled assembly language on YouTube, but YouTube is like recommending a whole bunch of assembly language stuff. Give me this video. And in this video, whatever, there's like feedback in this software. Everything, I'll assume stuff's working. I don't know. He says this is source code that took humans to the moon in 1969. So I want to like look at this assembly language, because modern programming is a form of information hiding. You can like call a function anything. You can convert it to floats, convert it to whatever you want, pretend something does something. But at assembly level, it's really hard to bullshit something. And I don't know. I find it really interesting. I don't know. I'm just gonna look into like the source code that took us to the moon in 1969. It's really weird that YouTube knew how to like recommend assembly language stuff, because I've never Googled assembly language videos. I always look up documentation, but then all of a sudden YouTube is like, hey, you want to see this video on assembly language? I don't know. It's a little weird. It's like I'm being watched or something. Anyways, well, we all know they watch us. By they, I mean Google. I mean the people that like sell you advertising on your phone. It's a total invasion of privacy. They probably have, most likely, pictures of us as we're pooping. And they probably save them and watch them back or something. It's something creepy. I don't know. These people that run Google and advertise to us off our own data, a bunch of fucking creepy perverts watching us poop, recording our voice, saving it to a database. Bunch of fucking freaks. Anyways, somehow they knew. By they, I just said who they was. Google, I guess. Whoever runs these data collections on citizens of the United States and other states and stuff. These people collect information, saving it to databases on us. I don't know. These people decided you might like this video, and I don't know. I might like it. So there is some assembly. I'm gonna look at it really quick, and I'm gonna get back to like programming, whatever. because I'm writing JavaScript engine. I'll get to it later. So I don't know. This does look really interesting.
Code that took humans to the moon in 1969. Usually, when you think about the moon landing, you think about these guys, the 3 brave astronauts that went to the moon. You probably also think about Saturn V, which was the rocket that was used to take them to the moon. But the actual source code that took us to the moon, the computer that took us to the moon, known as the Apollo guidance computer, unfortunately didn't get that much media hype, which...
So I don't know. I want to look at this assembly. I mean, the moon landing, it's unbelievable. I mean, it's like historical. So I'm gonna look at this code that sent us to the moon. I'm gonna use my investigative skills to look at this assembly. I don't know. So here we go. I have to like download it, I think.
ChatGPT, Compiler Explorer, This is the source code that sent humans to the moon in 1969, and it's even more amazing than you think. The Apollo Guidance Computer, AGC, was a true marvel of its time. I'm so glad that I learned so much about the
It's sad
AGC.
because even if
I
you're
take a
not
look at how this tiny computer achieved one of humanity's greatest accomplishments, and why its code, complete with jokes and Shakespeare, is still legendary today.
There's only one reason there would be jokes inside of code that sent us to the moon. A real programmer knows why there would be jokes in code. In release code, you never leave jokes in the code. Any jokes that were in there, you take them out. So I got jokes in my code, little stupid comments. But in the release code, you will never see that. So, I don't know.
Yeah, or you haven't coded well and saying that correctly. So we're just going to focus on the Luminar by a file called main.agc. So you'll see that there is a file called main.agc in each of the your lights from the astronauts to input game button, maybe even abort procedures. So sometimes they were quite creative with the names for specific sets of instructions. For example, another part of the code is called pinball game buttons and lights.
There's only one reason why. When you write code, you would call it pinball game buttons and lights. That is a huge clue. In release code, especially if you're going to go to the moon, you would never publicly release pinball game buttons and lights as a file name. So I want to look through this code. I don't know. It's really interesting stuff here. I cannot believe. I mean, the moon landing is just miraculous.
Code has nothing to do with pinball itself. Its name just reflects the fact that it likely contributes.
We all know what the name reflects, whatever. It's not that it, I don't know, whatever. I'm just gonna look at the code in a second. I love saying we all know. It's like manipulation 101. You get someone to like agree to something as like a general fact, and then you continue on from that point to the next general fact, and then you get people believing whatever it is you're saying you're believing. That's so shady when people do that. We all know. You know?
controls the interface between the astronauts and the AGC via the to others. So whoever wrote loaded with tasks. So seeing this may have been a bit of a surprise. By the bug, NASA intern Chris Gary uploaded the source code for the Apollo 11 guidance computer.
So I don't know. I'm gonna look at the source code. I might get to back to JavaScript or whatever. How old is this video? So it was last year? 2024? You think they would have released the moon landing code? Or the code that controlled the Apollo years ago? I guess they had to wait. I don't know why they would wait so long to release code, source code. Alright, so I got the zip. So it's probably the luminary. How big is this file? .6 megabytes. That's so small. That's it. I don't. Okay, wow. That's like such a small amount of code. That's multiple files. I'd expect like at least one file to be a megabyte. Some big ass file. But looks like a bunch of small little files in. I don't know, I'm gonna check through these files, I guess. Usually the Mac says like how many files are selected. I don't know, something's off with my settings, I guess. I like open all these at once. There we go. They're all open. I need to find the syntax whatever. I think there's a syntax. So packages. Okay, I found the assembly. Syntax, whatever. I don't have to use a stupid website now. I don't know, it's difficult to read. I think I like restart Sublime or something. So maybe syntax colored. Okay, I gotta figure out what CPU this is, I guess. I actually have to get to work or whatever. So this will count as my distraction when I get to work. Cause like, I'm trying to like simply get the fucking time. I'm not trying to send a rocket to the moon like NASA did. NASA sent people to the moon. I just want the time in Windows and accurate time so I can speed test and check some sim language to find out what's faster or not. That's what I want. I just want the time. But Windows in 2024, you can't get the accurate time. But in 1969, they were sending people to the moon. In 2024, you can't even get the time accurately on Windows 11 in the year 2025. 2025. I don't know. That seems a little bit ridiculous. If people could be sent to the moon in 1969, in 2025, why the fuck can we only get time as accurate as 15 milliseconds? It's precise as file time. They were precisely sending people to the fucking moon in 1969. In 2025, we can't get the system time that's accurate. I find this whole thing ridiculous. I don't know. Everything's unbelievable. I'll be.
Grave accent. The assembly language, AGCASM. What CPU did it run on? What registers did it have? What was the memory model? Did it map devices to memory, or was it interrupt-based? The assembly language, AGCASM you're referring to is used for programming the Apollo guidance computer, AGC, which played a central role in NASA's Apollo missions. It was a unique and influential early digital computer with its own architecture and assembly language. Here's a breakdown of its technical specifics. Brain, CPU, Apollo guidance computer, AGC, custom 15-bit word architecture plus 1 parity bit equals 16 physical bits. The AGC CPU is a custom designed by MIT Instrumentation Lab. Clock speed, 1.024 MHz. Made using RTL, resistor transistor logic ICs. Earliest form of integrated logic.
They went to the moon on 1.24 megahertz? Are you kidding me? Really? It only takes a megahertz to computationally calculate rocket system with human lives on it. Okay. That seems adequate enough, I guess.
Inbox tray, registers. The AGC had a small set of special purpose registers, register purpose A accumulator, primary arithmetic register, Q quotient register, used in division, Z program count,
Is this a 6502?
L link bit, carry overflow flag, essentially, BB backup register, temporary storage. X, Y, U general purpose storage S stack pointer T temporary register used during Operation C, senior, AR, ETCIO and control registers. What other CPUs have X, Y registers? Great question. The use of X and Y registers is a distinctive feature in some CPUs, especially in simpler microprocessor designs. Here's a spanner, CPUs with X and Y registers 1. MOS Technology 6502. Widely used in the Apple II, Commodore 64, NES, and other 8-bit systems. 2. WD enhanced 16-bit version of the 6005 used in the Super Nintendo Entertainment System, SNES.
I don't know if you what I'm getting at here.
has 16-bit X and Y registers. Super Nintendo Entertainment System, SNES. Commodore 64, NES. 3. Motorola 6809. X, Y, U general purpose storage. Brain, memory model, core memory, RAM, 2K words in block I, 4K words in block 2, Apollo 11 and beyond, non-volatile, retained values without power. ROM, fixed memory, 12K words in block I, 36K words in block 2. No true stack memory model as in modern CPUs, though subroutine return addresses were stored manually using TC and index instructions. Real-time clock pulses, 1 / 10-second ticks.
Well, I guess that's more accurate than Windows. No, I mean, less accurate. So maybe 15 milliseconds. 15 millisecond granularity per second isn't too much to ask for in 2024. I mean, 1/10 of a second back in 1969. I mean, I don't know how you can get precision at all with that kind of timing in real time. And you have 3 people on a rocket going to the moon, 1 megahertz computer, and precision timing such as
Real-time clock pulses, 1 / 10-second ticks.
so does it mean 10 ticks per second?
When you say real-time clock pulses, 1 / 10-second ticks, that means 10 ticks per second the resolution of the timer.
Oh my god. Can you believe that? They went to the moon on a CPU that runs at slightly over 1 megahertz with the precision of 10 ticks per second. So, 1 Mississippi, 2 Mississippi, 3. So, like, 1 Mississippi is a second. So, 1, 2, 3, that's like 10. That's very, very slow. That is so slow. That's unbelievable. I mean, that's amazing. That's spectacular. The fact that you can guide a rocket to the moon with the precision of 10 ticks per second, that is amazing. Man.
Yes, when I mentioned real-time clock pulses, 1 / 10-second ticks, in the context of the Apollo Guidance Computer, AGC, that does indeed mean stopwatch, 10 ticks per second, each tick is 1 / 10th of a second. Tick, what this means in practice. The AGC had a real-time clock that generated an interrupt every 0.1 seconds, that is, every 100 milliseconds. This interrupt was known as clock pulse interrupt or simply the time 1 interrupt. It allowed the AGC to track elapsed mission time, manage task scheduling in the real-time executive, perform time-based updates. like refreshing the DSKY display or sensor polling. What time of precision per second is needed to guide a rocket in flight? What tick of precision per second is needed to guide a rocket in flight? C. Cedilla. What tick of precision per second is needed to guide a rocket in flight? Great question. The tick rate, temporal resolution needed to guide a rocket in flight depends heavily on the precision required, the dynamics of the vehicle, and the capabilities of the onboard guidance computer and sensors. Brain. Why not just use 1000 Hz? 1 ms resolution because 1. Physics constraints. Rockets don't change direction instantaneously. Guidance works with smooth trajectories. 2. Sensor noise versus signal. Inertial measurement units, IMUs, have noise. Too high a rate without filtering causes instability. 3. Computational limits. Higher tick rates require more CPU power, memory, and power, especially critical in space systems. Don't give me HZ. How many ticks per sec is often 100, 1000 hertz in ticks.
Okay, so chatbot says we need 100, 200 ticks per second to guide a rocket system. And modern rockets are... Oh, that's bullshit. Okay, so the Apollo rocket had 10 ticks per second. They're saying you need 100 ticks per second. But modern rockets...
What was the speed of the Apollo 11?
I don't know. I'm gonna like look at the CPU really quick. I'm gonna try to, or whatever it says about the CPU. Then I'm gonna look at the assembly. Then I'm gonna try to like get back to work on JavaScript or whatever. Or making JavaScript engine that does JavaScript.
I need to read the ASM. What website lists the only 34 instructions and such? And is there an online emulator for the CPU? Absolutely. To dive into the Apollo Guidance Computer, AGC, assembly language, the 34 instruction set, and even emulate the CPU, here are the best resources.
Oh man, where'd the website go? This happens all the time with things that are fake. They just disappear. I mean, things that happen disappear. Because it was there and then it's gone. Oh, this looks like it's it. Wait, is this it? That's like 34. This is it? What?
The seat instruction RN1, 1 be modified such that LT0 and shear receives Nisha L treatment. The former WTL elurat Wolther, Teaturin, RL or TNE latter will be reduced to a S1 number 1 mem of Evkal tkli effects we out of the yantance of Q. to reduce the amount of DSKY operations that the user has to perform while accomplishing a partial or full rendezvous. A special routine, named Minky, for a minimum K-ing, has been included in Colossus. This routine will automatically sequence the rendezvous maneuvers targeting programs and will also handle execution of P20 for tracking purposes and of P40 or P41 for execution of the burn. P76 can also be automatically invoked to update the AGC after each LM burn. In nominal operations, the CSM is passive during the rendezvous and keeps computing LM targeting burns to follow its approach. The Minky controller will also automatically determine if multiple CSI maneuvers are needed, if the plane change maneuver is to be performed, and will perform 2 P35 calculations for 2 MCC, mid-course correction, burns. The sequence ends with execution of P79. The Minky controller can be activated at any of 6 different points in the rendezvous sequence. After selecting any of the rendezvous maneuver programs, P31, P36, the AGC will permit a choice between using the Minky controller or the manual procedure.
This sounds more like an airplane than a rocket. I don't know. Santa Claus is real too. You've just been a bad boy or girl this year and you didn't get your presents. That's why Santa is totally real. I've heard Santa has gone to the moon too, with Rudolph. But only back in 1969. Okay, so there's 34 instructions. We got TC, CSS, index, exchange. Exchange is going to swap between 2 registers, possibly the high and low. Most likely, but I don't know which register it is or which register combination. And mask is probably an AND instruction. We got exchange with the pointer. Does that mean a memory dereference? I'm not sure. So they are doing real math, at least. So something is real about this. Why can't I find the instruction set? It's like been erased from the fucking internet. Did people look into this before I did and I missed my opportunity? And they like removed it because they're like, fuck. Pull that shit back. Get it off the internet. Because I need to see the instruction set to like evaluate what the fuck it's doing. I can guess, but that's only based on what I know. I know quite a bit, but it's a guess unless I know. I need the instruction set manual. Not manual, table, whatever. What the hell? Where is the moon mission instruction set for the CPU? It's giving like every single link and they're all broken. Give me what I'm looking for. It's not on this website. This website be more laggy. Oh, here it is. Machine instructions. Oh, here we go. Confidential. Woohoo. Let's download this in case it disappears. I have so much memory wasted on holding PDFs for like CPU documentation, but not like moon related. This isn't beneficial in any way. Confidential. The Apollo guidance computer. This is so exciting. 1963. I thought it was 69. Took 7 years. To what, make the rocket? The PDF viewer doesn't work in full screen. Where's the mouse?
This documents Yonton's information affecting the national defense of the United States within the meaning of the espionage laws. Title 8. USC, Sections 793 and 794, the transmission or revelation of which in any manner to an unauthorized person is prohibited by law. Group 4 downgraded at 3-year intervals, declassified after 12 years.
Man, why can't they just release it all once? Probably because the truth hurts. So you gotta release the truth in pieces at a time because it's really gonna hurt when people find out Santa Claus isn't real. He's really just an airplane that was like dropping presents out of an airplane into kids' rooftops or something. What do I know? I've never guided a rocket, so I don't know. I would think that you'd need more than 10 seconds of precision in a CPU faster than 1 megahertz, or at least 4 backup CPUs in case that CPU were to die, because there's people on the rocket. So there should always be several redundant backup systems or CPUs all running at the same exact time in case one were to fail, because these are people's lives on the line. So I don't know. If I sent a rocket to the moon, it'd be I don't know. Safety and life would be a priority. I don't know how NASA. It seems like a shit show. I mean, they release documentation and it all disappears. I don't know. All this stuff's odd. I'm gonna look at the assembly in a second. See if this is even the instruction set. This doesn't look like the instruction set. I got exchange, I got CS, TS, mask, add, TC, is that 2 registers maybe? No, it's not. When you're looking at space or whatever, I don't know. No, this is related. I should just try to stay on one topic at a time. But when it comes to programming languages, they take I guess you have to come up with like a language based off something. Never mind. Like, it says a Go transfer routine. And in C, they have a Go-To. And I think Go-To comes from, I don't know. Everything is like related somehow to some origin. You know, like, it's weird how information relates and everybody gets the same idea from the same thing and they implement the same thing in different ways. But it's all really just the same exact thing from the other thing, based off another thing, from some other thing. Like nothing is really unique or whatever. It's like the same box with a different label. Kind of like people. Lots of people are like that. Very, 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 very few are unique. Bunch of motherfucking copycats.
-2. This is the second issue of the AGCIS, which is published to inform the technical staff of MIT-IL and RAID on about the Apollo Guidance Computer, AGC, subsystem. The various types of instructions provided for the AGC are defined in paragraphs 1580 through 1597 of issue 15. The machine instructions are listed in table 1512. This issue describes the execution of each machine instruction. Information pertaining to the machine instructions was originally taken from an advanced copy of MIT-IL Report R39-3 and later updated. The row marked +111 symbolizes the circuitry of the adder which, on command, adds the quantity +1 to an operand entered into input register X or Y.
It adds a quantity +1. Why the +1? It's because I don't want 0 as a value. Or is it to keep... Oh, here's my maybe the basic principle of it.
The basic principle of the adder operation has been described in paragraphs 1527 through.
Oh, they took the page out. Oh, here's the instructions. So here's exchange. So T is used to test, I guess. So all the test instructions have a T.
Test for -0. Transfer contents of WAs to SQG and set BR to if all bits are ones. TMZ, TOV, TP, TRSM.
So R means read. They're reading into a register. C means carry or clear or decrement counter. I'm just gonna try to look at assembly now.
Reset band write contents of WAs into B.
Is WA a wide accumulator?
Reset and write contents of WAs into A.
What's WAs? Oh, I'm just gonna look at this assembly now.
Instructions with address K referring to registers.
What's address key?
One. Instructions with address K. K typically represents a memory address operand or an immediate address value in the instruction. In the AGC instruction set, many instructions include a 15-bit address field, denoted as K, which points to a memory location or register. 2. Referring to registers, in the AGC architecture, some special memory addresses correspond directly to CPU registers or special purpose registers. So, when an instruction's address field K references these particular addresses, it's actually referring to CPU registers, not general memory.
Which means it's still in memory though. Oh, in context, of course. That helps. So I guess they had register banks back in 1969 or 1964, before they even started the rocket. So mapping things to memory isn't a new trick, I guess.
What it means in context. Certain memory addresses, K, are mapped to registers or special hardware units. When an instruction uses such an address K, it's accessing or manipulating those registers directly. This is somewhat like memory. Mapped registers, but for the AGC it's part of its architectural design.
Oh my god, this is the slowest computer ever. This is ridiculous. Are you kidding me? Look at this. The A register is at 0, X00, A0 in memory. 0, that's a nibble. That's 0 to 15. So register A is 15 bytes after register B. That's 15 bytes. I mean, wait, what's at 0 then? Is that the control register? Yeah, so register B is after this. So they used a nibble to represent 15 bytes. And A, the A register, maps to the memory location, the address in memory at A. That is hilarious. That is hilarious. The accumulator is the most important part, the adder unit of the CPU. It's the most important part of the CPU, and the adder unit is like the circuitry for the rocket, the CPU that sent people to the moon at 1 megahertz a second. It has 10 clocks per second of precision. The adder unit is memory mapped to memory at A in memory. It's not even a register. It's in memory. That's insane.
Address 0 times 00 A0 corresponds to the accumulator, A, register. Instruction, TS0 times 00 A0, means transfer to storage at address 0 times 00 A0. Because 0 times 00 A0 refers to the accumulator, this instruction writes the current accumulator contents to that register, or accesses it in some special way.
Some special way, alright. They went to the moon in a special ass way. Special doesn't even. It's not enough. Spectacular. Miraculous.
In summary, the address key in instructions isn't always just a memory address. Some addresses correspond to special registers. So instructions with address key referring to registers means those instructions operate directly on those registers by using their assigned addresses.
Okay, maybe it has nothing to do with the K7. That was just a wild guess. And I was wrong. Horribly wrong. AMD is calling it your CPU the K7 for Kryptonite. I thought maybe they called it the K7 because in here they say
The address key in instructions isn't always just a memory address.
so. I thought K7 had to do something with address K in memory mapping because they say
Address key.
and there is no such thing as a K address because K isn't in hexadecimal. The hexadecimal is 0 to 9, A, B, C, D, F. There is no K. So, the AMD K7 CPU, I thought, okay, does that relate to address K? And no. I don't know. This is what Chatbot says. It's probably right. It probably doesn't have anything to do with the address K. That's probably not why they called it K7. Because there is memory mapping and stuff in the K7. But it has nothing to do with address K or whatever.
Brain. Meaning behind K71. K equals kryptonite. Unofficially.
Maybe it did. Maybe K stands for address K, which means magical addressing. Not to the moon landing and rocket, just whatever K is used to signify.
Internally, AMD engineers jokingly said K stood for kryptonite, a reference to defeating Intel, the Superman of the CPU world at the time. It was a continuation of the K-series codename tradition.
So, K doesn't really mean kryptonite. It means something else.
AMD engineers jokingly said K stood for kryptonite.
So whatever K means in the fact of the AMD K7, I don't know. But when it comes to the CPU that guided the rocket to the moon, address K means this.
Address K referring to registers means those instructions operate directly on those registers by using their assigned addresses.
So, K and address K can mean different. Can mean whatever it means. It's not always related, but it could be. Who knows? If it was related, it still doesn't matter. Okay, I don't know. I'm looking at something now. Then this is like moon mission assembly for a special moon mission CPU. The CPU did exist, and it does look like there's real math going on. So something is real about it. To me, it looks more like an airplane, not a rocket, based on the wording and stuff. But after that, after I'm done with this distraction, this is real assembly for x86, which is a modern CPU that's been updated for so many years now. It's still the same x86, just different virtualizations extended to it, whatever. And I have like, I don't know, I'm gonna try to time this stuff. I want accurate timing. But on Windows, in the year 2024, 2025, you can only get 15 millisecond accuracy. I don't know, I said this earlier. So like, I kind of have a way that I'm going to try to like time stuff. I am getting bored of looking at this rocket ship stuff. And the whole moon landing thing is getting boring now. So I'm going to get to work in a minute. I'm going to look at this assembly really quick though. It looks like some instructions with S mean store, and most of them with T mean test. So I don't know. I kind of like look through it. I kind of have some idea of how it probably works. If it's wrong, it's wrong. If it's not, I don't know. I'm just gonna like look at this assembly. So I want to try to find the main. Here's the main. Is this thing just one big file then? Is this how main used to look before C? Because this would make more sense. It's not even a program, it's just a collection of all the files ordered in the order that they need to be included in. So this does look like real code at least. So I want to look for assembly operation information, AGC, because that's at the top. This is so interesting.
Assembly and Operation Information AGC. Assembly and Operation Information AGC.
Of course, chatbot can't, not chatbot, Siri can't read what's in Sublime, so I have to friggin' copy paste it.
Page 1. This LGC program is intended for use in the LM during the manned lunar landing mission or any subset thereof. The details of implementation are specified in Report R567, as amended. Guidance System Operations Plan for manned LM Earth orbital and lunar missions using Program Luminary. Grave accent. What's the Q axis? Why not use XYZ axis? The Q-axis is a term primarily used in rotating reference frames, especially in electrical engineering, SC motors, and control systems. Not typical 3D space. If you're asking why not just use XYZ, here's why. Brain. What is the Q-axis? The Q-axis appears in the context of gear 1. SC motor control, field-oriented control fog. In electric motors like BLDC or AC synchronous motors, we use a rotating coordinate system, known as the DQ reference frame, to simplify torque and flux control. The Q-axis current, I, sub Q, sub, directly controls torque. These are not spatial axes like X, Y, Z. They are in a rotating reference frame that moves with the rotor's magnetic field. Brain. Think of it like this. X, Y, Z are like map directions fixed. D, Q are like car relative directions. D is straight ahead, aligned with rotor. Q is sideways perpendicular to rotor. Do planes use Q-axis to describe the flaps that control drag and such? Do airplanes use Q-axis to describe the flaps that control drag and such? Great question, and the short answer is no. Airplanes do not use the Q-axis to describe flaps, drag, or flight control surfaces. Instead, aviation. Small aeroplane. What axes do airplanes use? Aeroplane, standard aerospace axis, body fixed coordinate system, axis name direction contrasts axis longitudinal nose to tail roll, via ailerons, y-axis lateral wingtip to wingtip pitch, via elevators, z, axis vertical bottom to top, downward in aircraft frame, yaw, via rudder. This system is body fixed, meaning the axes move with the plane. Chart with downwards trend. What is Q in aerospace then? Now here's the twist. There is a variable Q in aerospace, but it's not an axis. It's Q equals dynamic pressure equals 122 where equals air density equals airspeed. Dynamic pressure is used in aerodynamic force calculations. For example, lift equals drag equals. So Q in aeronautics is not an axis. It's a scalar pressure term.
Okay, so they set up whatever something's presumed at something. It has if it's true. Do store operations. Test is the time. 2 seconds. No compute drive time. Drive time must be greater than 2. Turn off the gimbal. And they save key for return. Initial guess is at the root 1/2 of position max. The product is delta times omega plus alpha and multiply skilled factor returned. Add the K2 this assign. So it looks like this tests for it says RCS autopilot determined that the vehicle was entering or had entered a coast zone with a small offset angular acceleration. Is this a car? This is a motor, a vehicle. This isn't a rocket. I'm gonna look at this later. Is this all for only the moon landing, lander, whatever? Or does this include that little go-kart they drove on the moon? Because they would use DC motors to turn a rocket, or the jets, whatever you want to call them. But I don't know. I'm gonna just click on some of the more interesting looking files first. But this looks like the file in something needs to be positioned a certain way, and it tests in real time, and if it's not, then it triggers something, and then it tests, and it triggers, and it tests until some conditions met, and then it stops triggering responses until some conditions not met, and it triggers it. So it sounds like it's trying to like level out or stabilize something. Which could be applied to like anything, not just a motor or a rocket. It could be like a really general case, whatever. So I don't know. Whatever routine's being called for, I'm just clicking through the files. But it does look like it does something. And it looks like, I don't know, whatever. They like predict it after they do the response. They predict a result. If it's not the result, then they chop away at it. Like I think it said guess by 2, twice the amount, or guess this. So it's like test response, whatever the routine relates to in that file. I don't know. This seems too simple. It says save user's alarm code, save users, queue, don't move, return to user. Wouldn't the stuff already be programmed into the memory before? Why would you have to program things into memory after it's already been running? Or maybe they have a memory bank, like a hard drive, and if they have to add new users later, they could put them in, and this routine would do that or something. But to save on memory, I thought that like, or it would seem to make more sense to pre-save everything beforehand. I don't know. It seems like this computer actually has readable, writable memory, and they're using it for that. Like, computers weren't actually that unadvanced. They might have just been slow, but they could actually do everything that computers do now, just much slower. Does IQ mean initial quota? Since epsilon is measure of the coupling and is defined 1 IQ or IR for is that interrupt request. The computed expression is equivalent epsilon to maximum. Mass is divided by acceleration and gravity. I thought there's no gravity on the moon. In order to match the units of x, y, or space, I mean, which are x, the ratio of acceleration. If gravity is the same metric energies, so that is unconverted. 2.20 converts. Oh, what's this? They're like addressing the fact that something is really weird going on in the file. And they had to add to the file. At least they didn't destroy it. And they like kept it in here. I don't know, like have Siri read this or whatever. And I'm gonna get this is getting boring now. Here's a note from the files.
Ramindo Cute, N. Alonso, one of the original AGC developers, provides a little more insight. Apparently, nobody had yet arrived at any kind of software requirements for the AGC's user interface when the desire arose within the instrumentation laboratories to set up a demo guidance computer unit with which to impress visitors to the lab. Of course, this demo would have to do something if it was going to be at all impressive, and to do something it would need some software. In short order, some of the coders threw together a demo program, inventing and using the verb-noun user interface concept in the whimsical fashion seen in much of this code, but without any idea that the verb-noun concept would somehow survive into the flight software. As time passed, and more people became familiar with the demo, nobody got around to inventing an improvement for the user interface, so the coders simply built it into the flight software without any specific requirements to do so. BR. However, that does not mean that the verb-noun interface was universally beloved. Ramindo Cute and says that many objections were received from naysayers, such as it's not scientific, it's not dignified, or even astronauts won't understand it. Even though the coders of the demo hadn't seriously intended the verb-noun interface to be used in any permanent way, it became a kind of devilish game to counter these objections with, perhaps, sophistic arguments as to why the interface was really a good one. In the end, the coders won. I don't know whether they were related or dismayed by this victory. The astronauts. Of course, could understand the interface, but they did not like it. Most of them really wanted an interface much more like that they had used in aircraft. That is, lots of dials and switches. Dave Scott is the only astronaut I'm aware of who had kind words for it, or for the AGC in general, Though we are told that Jim McDevitt wasn't necessarily completely hostile to it. BR. Div style equals text align, right, small, and dash, Ron Berkey, 07/2009, small, div. More like that they had used in aircraft.
That's probably why things are worded like an aircraft. Or in relation to aircrafts. In this stuff, whatever. So this is just for the display. Or, I don't know, when here it says if angle is 0 or 180 degrees, do nothing. Compute 360 degrees minus angle.
Page 425. Load verbs if alarm condition is detected during execute. Check fail light is turned on and end of job. If alarm condition is detected during enter of data, check fail is turned on and IT recycles to execute of original load verb. Recycle caused by 1. Decimal machine. CADR 2. Mixture of octal decimal data 3. Octal data into decimal. Only noun 4. Dec data into October only noun 5. Data too large for scale. 6. Fewer than 3 data words loaded for HRS. Min. SEC noun. 2. 6. Alarm and recycle occur at final enter of set. 1. Alarm and recycle occur at enter of CADR. Page 450. Key release routine. This routine always turns off the opaque light and always clears block. The highest priority function of the key release button is the unsuspending of a suspended monitor which was externally initiated. This function is accomplished by clearing block and turning off the key release light if both SPLIST and cadruster are empty. If no such monitor exists, then RELDSP is executed to cleared block, and the external monitor bit, freeing the display system for internal use. Turn off the key release light, and wake up any job in SPLIST. In addition, if there is a job in EndIdle, then control is transferred to pin branch in display interface routine to re-execute the series of NVSUB calls etc. that preceded the EndIdle call, still awaiting response. This feature is intended for use when the operator has been requested to respond to some internal action that used EndIdle, but he has written over the information on the display panel by some displays of his own initiation which do not serve as responses. Hitting kills will re-establish the displays to the state they were in before he obscured them, so that he can see the waiting request. This works only for internal programs that used EndIdle through Margaret's display subroutines.
This may, I don't know.
XBlock is the interlock for use of keyboard and display system which locks out internal use whenever there is external keyboard action. NVSUB should be used twice in succession for please perform situations. Similarly for please mark. First, place the coded number for what action is desired of operator into the registers referred to by the checklist noun. Go to an NVSUB with a display verb in the checklist noun. Go to an NVSUB again WTIH the please perform verb and zeros in the low 7 bits. This pastes up the please perform verb into the verb lights, and monopt is an entry similar to an NVSUB, but requiring an additional.
Is this like a video game?
This pastes up the please perform verb into the verb lights.
It's like a little show. And they're like, astronaut number 480, please perform this task. And they click a button, and then it's like they insert the verb into the program to say what the task is or something. What? It's like it's like they're making the thing go like beep bop bop boop boop and putting on like a little show or something. And they're telling the astronaut, like, please perform this task. It's like if you put a random number in a random number machine and you're testing for certain conditions, and if something happens, then you're like, oh, an action needs to be carried out. And it gets passed in, and something catches it, and then it goes like,
Pastes up the please perform verb into the verb lights.
this seems like they're controlling what's going to happen, or they know what's going to happen. I don't know. It's like a game show or something. That's probably why they called it pinball game. Buttons and lights. What the heck is planary inertial orientation? I finally found the word moon. So Earth, MX, Moon, MX. Subroutine exists. Vector moon, C vector moon, LRP vector, AP vector moon, matrix. So this is definitely related to the moon. I saw a bunch of like, it looked like an airplane, but now I see the word moon. Definitely moon related.
And monopt is an entry similar to an NVSUB, but requiring an additional page 452 parameter in LIT should be used only with a monitor verb noun code in. After each monitor display, a please verb will be pasted into the verb light or data will be blanked, or both according to the options specified in elif bits 814 of elu rather than 0. Then they will be interpreted as a verb code and pasted in the verb lights. This verb code should designate one of the please verbs. If bits 1, 3 of L are other than 0, then they will be used to blank data by being fed to blank sum. If nvmonot is used with a verb other than a monitor verb, the parameter in L has no effect. NVSUB in fixed places 2 plus calling lock int NVQTEM. T scene subandinter. Enter it. This will restore old calling bank bits.
Because if bits 1 of 3 and 0, they're used to blank the data. If it's used with a verb other than monitor verb, the parameter has no effect. So like, what, it waits until it gets the response it wants, and it says that we use to blank the data. It's like I don't know. I'd have to like read all this to figure it out. But it seems like the code's like rejecting and denying, confirming stuff based on conditions or something that are input. And it says things like,
Please perform.
so I don't know. I should get back to work. So does this code, other file, pull up nouns from this file to present data to display? It doesn't know what it's going to pull up until it gets the noun or the verb, whatever it is, from this file. So I don't know. This file's called pinball noun. Pinball noun tables. So I found the word moon in here. It looks like it's a constant. So it has to do with the moon, whatever this is. So I don't know. I gotta get to work. This is getting boring now. Oh, BRB. But this definitely has something to do with the moon, because I finally found the word moon and earth in this documentation. So, I don't know. I'll BRB. And I'll get to like disassembly and stuff. Okay, so about the moon landing thing, whatever. Not the moon landing. The code used on the CPU and whatever system it was that they used for the moon module, whatever. I do believe that it did have something to do with the moon, because in here, in the code, the word moon shows up. So, it has something to do with the moon. But in this file, pinball game, buttons and lights, whatever. To me, what it sounds like when reading through it, it sounds like maybe the computer will ask like, please input the delta, the D and G axes, and then it expects a certain value within a certain range. So if you put in 0, it'll clear the display. If you put in 180, it'll clear the display because it doesn't want 0 or 180. And then it has like it has requirements or whatever. So that kind of makes sense because you type in like the degrees for delta and like 1.2 point something, and there's like a limit to the range of the number. And if you go over it, it makes sense that the screen would display, or the display, whatever, would like clear what's on display to indicate that you typed in a wrong number. But like, I don't know what pinball relates to. Maybe they used code from a pinball machine, and it's like, please insert coin. Is that what they're getting at? Because it says block display on system, make display busy, disabled for air, light reset, all keys except turn on. This means reset flashing display, which he obscured with displays of zone. So like, okay, so I actually need to get to programming. It says most of them really wanted an interference, much like that they had in an aircraft. Lots of dials and switches. It says it's not scientific, it's not dignified, or even astronauts don't understand it. It also says set up a demo guidance computer unit with which to impress visitors in the lab. Apparently nobody had yet arrived at any kind of software requirements for the ArcSys user interface when the desire arose within the instrumentation laboratory to set up a demo guidance computer unit with which to impress visitors of the lab. Apparently nobody had yet arrived at any kind of software requirements. So they made the ArcSys user interface Why would they design it if they didn't have software requirements in the first place? Why would they design something that had no purpose until it had a purpose? And then it says, this whole thing is shady. Okay, so I was getting at though, it's down here. They want lots of downs and switches because you don't want to like have to digitally type in the coordinates or rotation of degrees, hit enter. And on top of that, the system, when it updated the display for input, whatever, it says like, and right here it says they wanted to impress visitors to set up a demo guidance computer with which to impress visitors. So it's like, I don't know, like a little show. Kind of like I was saying earlier, it seems the code like it's reacting to external input, but it's overly dramatic. And how it's like reacting, it doesn't seem like they would have used it in real use. Because even here it says most of them really wanted an interface like they use in an aircraft, lots of dials and switches. So did they actually use this system on the rocket? That'd be ridiculous. Like a dial and switch, you can rotate it to the degree you want, hit enter. But with this, you have to like type it in to a fucking keypad. And then down here, it's like resetting the screen, it's doing all this shit. Can't find. Where's that? Like right here.
NVSUB should be used twice in succession for please perform situations. Similarly for please mark. First, place the coded number for what action is desired of operator into the registers referred to by the checklist noun. Go to an NVSUB with a display verb in the checklist noun. Go to an NVSUB again WTIH the please perform verb and zeros in the low 7 bits. This pastes up the please perform verb into the verb lights.
So, does that mean like they'd be like, please perform inputting the DEQ coordinates and you type in your coordinates? Or is it saying that the action is in place of please perform? I don't know. The whole thing. I had to like really read through it to figure it out. But something's off. It's a little weird. So I'm gonna not get distracted with the space stuff. It's interesting.
What does this mean? Ramando Cute. N. Alonso, one of the original AGC developers, provides a little more insight. Apparently, nobody had yet arrived at any kind of software requirements for the AGC's user interface when the desire arose within the instrumentation laboratories to set up a demo guidance computer unit with which to impress visitors to the lab. At that point in the project, they hadn't officially defined how astronauts would interact with the AGC, no clear UI UX design, no buttons or display layouts, etc. In modern terms, they hadn't written any user stories or functional requirements for the interface yet.
If they're going to the moon, wouldn't the first thing be how are astronauts gonna interact with the rocket ship? Or something? The spacecraft, whatever you want to call it. Because how are you gonna fly the thing if you can't even interact with it?
Small Blue Diamond nobody had yet arrived at any kind of software requirements for the AGC's user interface. At that point in the project, they hadn't officially defined how astronauts would interact with the AGC, no clear UI UX design, no buttons or display layouts, etc. In modern terms, they hadn't written any user stories or functional requirements for the interface yet.
Oh, that's why it's included. Because they never actually wrote a functional user interface. So they went to the moon with this user interface because nobody made a functional user interface because nobody requested one. Oh, that's hilarious. That's gold. It says, the astronauts, of course, understood the interface, but they did not like it. Most of them really wanted an interface. Much more. Yeah, because they don't want a video game, a little show. They wanted one much more like they had in an aircraft. Lots of dials and switches. Dave Scott is one of the only astronauts I'm aware of who had kind words for it. Though we are told that Jim McDivitt wasn't necessarily completely hostile to it. Many objections were received from naysayers saying it's not scientific, it's not dignified, or even astronauts won't understand it. Even the coders of this demo hadn't seriously intended it to be used in any permanent way. Oh my god! Are you fucking kidding me? They went to the moon? Oh, this is so unbelievable. This is hilarious. They never intended it to even be used, but they used it to go to the moon. And it was never intended to be used because
Small Blue Diamond nobody had yet arrived at any kind of software requirements for the AGC's user interface. At that point in the project, they hadn't officially defined how astronauts would interact with the AGC. No clear UI UX design. No buttons or display layouts, etc. In modern terms, they hadn't written any user stories or functional requirements for the interface yet.
so, since they didn't have any way, even though it's designed for space, for the astronauts to use the system, they had no way for the astronauts to use a system designed for astronauts in a spaceship, an aircraft, a spacecraft we want to call it. But then
Arose within the instrumentation laboratories to set up a demo, guidance computer unit with which to impress visitors to the lab.
So, since they never actually made an interface, of course Siri stopped working. So I'm gonna have to read it. So, they never actually had an interface designed. Why is Siri? This computer is a piece of shit. So, they never had anything designed for interface. Is that even the coders of the demo hadn't seriously intended the verb noun interface to be used in any permanent way, which means they used this system setup computer won't even zoom. So they set up a demo guidance computer unit with which to impress visitors at the lab. So they went to the moon using a system, an interface, not even designed in the first place for anything other than to impress visitors at the lab. So the Apollo guidance system, its user interface, was never even designed for space. It was designed to impress visitors to the lab. Because it says, even though coders hadn't intended the nonverb interface to be used in any permanent way, and by permanent way, they mean they never intended for it to be used on the fucking spacecraft. Because it shows up in the assembly for the code that they used to land man on the moon. That's gold. I don't know. I'll be. I'm actually get to work now. I'm done looking into this. So I need to like restart this computer because something has failed on it. The command key is not working and I can't like zoom it out. I can't even hit Control S, so I like restart something. It says the bottom line. The passage highlights a classic story in engineering history, just like the moon. History. Sometimes, real systems are born from ad hoc demos and showpieces, and then they stick because they're effective and everyone loves them. So, the AGC user interface started as a demo to impress people before it became astronauts' primary tool for flying to the moon. Let me know if you'd like to see photos or breakdowns of how this key worked. Oh, I know how it worked. It worked so well. Not only was it an ad hoc demo and showpiece, it was the user interface for flying to the moon. I mean, unbelievable. And that's the bottom line. Oh, I can't save print screen. Oh, I can save print screen on this computer. Okay, so I gotta restart this computer because it's failing. And I'm gonna get to... I can't hear anything now. I'm gonna get to program whatever. So, this isn't as complicated as moon landing. I don't know how loud I'm talking or how fast I'm talking because I can't hear what I'm saying because the computer's restarting. Except, basically, on the modern operating system, 2025, you can't get precise time. It comes in a high granularity of like 10 to 15 milliseconds. That's not suitable for testing assembly, language, code, or whatever. So, I'm going to be getting the CPU cycles, the timestamp. That's not relative to physical time. It's CPU time. And it's not even comparable because the CPU has clock boosts and stuff. And it's not stable all the time. I don't know. So there's real time. And then there's CPU cycle time. And I'm going to get CPU cycle time before and after calling to get precise file time. That's real time. And then I'm going to benchmark the code, and then I'll call CPU cycle time again. Then get system precise file time, then CPU cycle time. And I can subtract the difference between the cycle time before with file time between. And that's like my start point, somewhere between here in the middle, is the CPU cycle time when get system is file time. So then I can tie the cycle time to when the system time started. Because if I call cycle time and then system time, I really don't know how long it took after calling cycles to call system. So if I call cycle timestamp, then system time, then cycle timestamp, I can do cycle timestamp minus cycle timestamp, and somewhere between there, so I can divide that by 2, start minus end divided by 2, or I can add them up and divide it by 2. So add them up, divided by 2, and that's the average. So the average will be what I would assume to be when get system as file time was called. So I'm going to do that before and after the benchmark. And after the benchmark, I can subtract the result of the CPU cycle timestamp plus CPU cycle timestamp divided by 2. And before and after, I can subtract those to get the difference. And then I have the physical time, it's not precise. And then I have the CPU time that is precise, but not based on physical time. And from that, it should be possible to judge which assembly code runs faster. I don't know if I can convert the cycle time to real time because there's no base. Per interval or whatever. So I don't know. But basically, I have a macro to make lists with a keyword. So I think I'm going to wrap those with the new macro. I'll make a new macro to print lists. So I'm going to modify some of the macros I have, I think. So I can make a separate module for different chunks of code for Visual Studio, Clang, and then my assembly to compare them all. And they'll all be templated, so it'll do the same exact thing, whatever, to get accurate timings and stuff. So I have to log into the Mac and turn it on. But I think I'm going to start that and see where I get or whatever. And I should be able to test some assembly today. Like real assembly, not moon landing assembly. In my assembly, whatever, it's not for like a little show at a lab. It's real. So I don't know, I just want to throw that in there. Testing, testing. Now it's working. So, I don't know. I'm gonna get started, whatever. I have a macro, like these counters and stuff. I think I'm gonna wrap them. I'm gonna make a new macro. That's gonna call the other macro I have. And I'll make like an enum to define options for the macro. So I can pick other macros to include that or other things. And then when I make I changed the color of the theme. Now I can't find anything because I was looking at it. It was green yesterday. But now I made it back to this theme. And I can't remember where things are. I'm gonna change the color. There we go. Okay, here. So I made 3 lists: log position, highest best, benchmark, wall clock, and benchmark CPU cycles. I think I'm gonna have to make a macro that holds this macro, and then I'll call it to like, I don't know. I gotta simplify what it's gonna do because there's no reason to make this super complicated. It just has to work because I need to get done and actually get to convert the rest of the program. I need to find a USB cable. 1 second. Never mind. Finding USB cable is gonna be a lot of work. I can't find it. So, I don't know. I'm gonna get to making macros, do this stuff now. So I'm just gonna get to work or whatever. I don't know. It's not exciting. I kind of have it like set up from yesterday. So I gotta like just go back through whatever and move some stuff around, rename it and stuff. Make a backup first. And Windows just keeps moving these freaking windows around. Somehow, man can go to the moon. But Windows, you know what? It doesn't matter. It's not worth complaining. I'm just gonna fix the Windows. Get started on working. I wish things would just like stay constant and work. Or like you set a setting and it doesn't forget it. There's lots of things I would like that make life easier. But nope. So I'm gonna try to get to work, I guess.
For function code, parameters are also added as bindings to that environment record. Which environment record is used to bind a declaration and its kind depends upon the type of ECMAScript code executed by the execution context. But the remainder of the behavior is generic. On entering an execution context, bindings are created in the variable environment as follows using the caller-provided code and, if it is function code, argument list args. Let env be the environment record component of the running execution context's variable environment. If code is eval code, then let configurable bindings be true, else let configurable bindings be false. If code is strict mode code, then let strict be true, else let strict be false. If code is function code, then let func be the function whose internal method initiated execution of code. Let names be the value of func's internal property. B let arg count be the number of elements in args. C let n be the number 0. D for each string arg name in names. In list order do, I let n be the current value of n plus 1, 2. If n is greater than arg count, Let v be undefined, otherwise let v be the value of the nth element of args. 3. Let arg already declared be the result of calling env's has binding concrete method passing arg name as the argument. If arg already declared is false, call env's create mutable binding concrete method passing arg name as the argument. V call env's set mutable binding concrete method passing arg name v and strict as the arguments. For each function declaration f in code, in source text order do, a let fn be the identifier in function declaration f. B let fo be the result of instantiating function declaration f as described in clause 13. C let fun env's has binding concrete method passing fn as the argument. D if func already declared is false, call env's create mutable binding concrete method passing fn and configurable bindings as the arguments. Call env's set mutable binding concrete method passing fn, fo, and strict as the arguments. Let arguments already declared be the result of calling env's has binding concrete method passing arguments as the argument. If code is function code and arguments already declared is false, then a let args obj be the result of calling the abstract operation create arguments object. 10.6 passing func names args env and strict as arguments. B if strict is true, then I call env's create immutable binding concrete method passing the string arguments as the argument. 2. Call env's initialize immutable binding concrete method passing arguments and args obj as arguments. C else I call env's create mutable binding concrete method passing the string arguments as the argument. 2. Call env's set mutable binding concrete method passing arguments args obj and false as arguments for each variable declaration and variable declaration no in D and C. Ode. In source text order do, a let dn be the identifier in D. B let var already declared be the result of calling env's has binding concrete method passing dn as the argument. C if var already declared is false, then I call env's create mutable binding concrete method passing dn and configurable bindings as the arguments. ECMA International 2009 59. 2. Call env's set mutable binding concrete method passing dn, undefined, and strict as the arguments. 0.6 Arguments object. When control enters an execution context for function code, an arguments object is created unless is specified in 10.5. The identifier arguments occurs as an identifier in the function's formal parameter list or occurs as the identifier of a variable declaration or function declaration contained in the function code. The arguments object is created by calling the abstract operation create arguments object with arguments func. The function object whose code is to be evaluated names a list containing the function's formal parameter names. Args the actual arguments passed to the internal method. Env the variable environment for the function code, and strict a boolean that indicates whether or not the function code is strict code. When create arguments object is called, the following steps are performed. Let len be the number of elements in args. Let obj be the result of creating a new ECMAScript object. Set all the internal methods of obj as specified in 8.12. Set the internal property of obj to arguments. Let object be the standard built-in object constructor. 1.5.2. Set the internal property of obj to the standard built-in object prototype object. 1.5.2.4. Call the internal method on obj passing length, the property descriptor len, true, false, and false as arguments. Let map be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. Let mapped names be an empty list. 0. Let index equals len1, 1. Repeat while index equals 0. A let val be the element of args at 0 origin list position index. B call the internal method on obj passing to string index, the property descriptor val, true, and false as arguments. See if index is less than the number of elements in names, then I let name be the element of names at 0 origin list position index. 2. If strict is false and name is not an element of map names, Then add name as an element of the list map names. Let G be the result of calling the make arg getter abstract operation with arguments name and env. Let P be the result of calling the make arg setter abstract operation with arguments name and env. Call the internal method of map passing to string inx the property descriptor G true and falses arguments D. Let index equals index1 2. If map names is not empty, then A. Set the internal property of obj to map, B. Set the and internal methods of obj to the definitions provided below. 3. If strict is false, then A. Call the internal method on obj passing call E. The property descriptor func true, false, true, and false as arguments. 4. Else strict is true so 0. ECMA International 2009 AB. Let thrower be the function object 1 3 2 3. Call the internal method of obj with arguments caller property descriptor thrower false false and false. C. Call the internal method of obj with arguments call E property descriptor thrower false false and false. 5. Return obj. The abstract operation make arg get called with string name and environment record env creates a function object that when executed returns the value bound for name and env. It performs the following steps. Let body be the result of concatenating the strings return, name, and return the result of creating a function object as described in 13.2 using no formal parameter list. Body for function body, env as scope, and true for strict. The abstract operation make arg set called with string name and environment record env creates a function object that when executed sets the value bound for name and env. It performs the following steps. Let param be the string name concatenated with the string arg. Let body be the string name equals param with name replaced by the value of name and param replaced by the value of param. Return the result of creating a function object as described in 13.2 using a list containing the single string param as formal parameter list, body for function body, env as scope, and true for strict. The called with a property name P performs the following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing P as the argument. If the value of is mapped is undefined, then A, B, let V be the result of calling the default. If P is caller and V is a strict mode function object, throw a type error exception. Return V, C, else. Map contains a formal parameter mapping for P, so A return the result of calling the sing P as the argument. The internal method of an arguments object for a non-strict mode function with formal parameters when called with a property name P performs the following steps. Let desk be the result of calling the default internal method 8 1 2 1 on the arguments object passing P as the argument. If desk is undefined then return desk. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing P as the argument. If the value of is mapped is not undefined, then A set desk to the result of calling the return desk. The internal method of an arguments object for a non-strict mode function with formal parameters when called with a property name P, property descriptor desk, and boolean flag throw performs the following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing P as the argument. Let allowed be the result of calling the default internal method 8 1 2 9 on the arguments object passing P, desk, and false as the arguments. If allowed is false, then if throw is true then throw a type error exception, otherwise return false. 5. If the value of is mapped is not undefined, then ECMA International 2009 61. If is accessor descriptor, desk, is true, then I call the internal method of map passing P, and false as the arguments. B else I if desk is present, then call the, and throw as the arguments. 2. If desk is present and its value is false, Then, call the internal method of map passing p and false as arguments. Return true. The internal method of an arguments object for a non-strict mode function with formal parameters. When called with a property name p and boolean flag throw performs the following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing p as the argument. Let result be the result of calling the default internal method 8, 1, 2, 7 on the arguments object, passing p and throw as the arguments. If result is true and the value of is mapped is not undefined, then call the internal method of map passing p, and false as the arguments 5. Return result. Note 1 for non-strict mode functions the array index, defined in 15.4, named data properties of an arguments object whose numeric name values are less than the number of formal parameters of the corresponding function object initial. Why share their values with the corresponding argument bindings in the function's execution context? This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. For strict mode functions, the values of the arguments object's properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 2 the parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly accessible from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note 3 arguments objects for strict mode functions define non-configurable accessor properties named caller and callee, which throw a type error exception on access. The callee property has a more specific meaning for non-strict mode functions, and the caller property has historically been provided as an implementation-defined extension by some ECMAScript implementations. The strict mode definition of these properties exists to ensure that neither of them is defined in any other manner by conforming ECMAScript implementations. 1 Expressions 1.1 Primary expressions. Syntax. Primary expression. This identifier literal array literal object literal expression 1 at this keyword. The this keyword evaluates to the value of the this binding of the current execution context. 2 Copyright sign. ECMA International 2009 111. 2 Identifier reference. An identifier is evaluated by performing identifier resolution as specified in 103.1. The result of evaluating an identifier is always a value of type reference 113 literal reference. A literal is evaluated as described in 7.8.111. 4 Array initializer. An array initializer is an expression describing the initialization of an array object, written in a form of a literal. It is a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. Array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal. Eligenort. Element list. Element list. Eligenort. Element list. Eligenort assignment expression. Element list. Eligenort assignment expression. Elision. Semantics. The production array literal. Eligenort is evaluated as follows. Let array be the result of creating a new object as if by the expression new array, where array is the standard built-in constructor with that name. Let pad be the result of evaluating elision. If not present, use the numeric value 0. Call the return array. The production array literal element list is evaluated as follows. Return the result of evaluating element list. The production array literal element list eligenort is evaluated as follows. Let array be the result of evaluating element list. Let pad be the result of evaluating elision. If not present, Use the numeric value 0. Let len be the result of calling the return array. The production element list eligible assignment expression is evaluated as follows. Copyright sign ECMA International 2009. 3.1. Let array be the result of creating a new object as if by the expression new array, where array is the standard built-in constructor with that name. Let first index be the result of evaluating elision. If not present, use the numeric value 0. Let init result be the result of evaluating assignment expression. Let init object value init result. Call the internal method of array with arguments to string. First int x, the property descriptor, init value, true, 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 and false. Return array. The production element list eligible assignment expression is evaluated as follows. Let array be the result of evaluating element list. Let pad be the result of evaluating elision. If not present, use the numeric value 0. Let init result be the result of evaluating assignment expression. Let init object value init result. Let len be the result of calling the call the internal method of array with arguments to string. 32 pad plus len and the property descriptor init value true, 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 and false. Return array. The production elision is evaluated as follows. Return the numeric value 1. The production elision is evaluated as follows. Let preceding be the result of evaluating elision. Return preceding plus 1. Note is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 5 object initializer. An object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property names and associated values, enclosed in curly braces. The values need not be literals. They are evaluated each time the object initializer is evaluated. Syntax. Object literal. Property name and value list. Property name and value list. Property name and value list. Property assignment. Property name and value list. Property assignment. Property assignment. Property name. Assignment expression. Get property name. Function body. Set property name. Property set parameter list. Function body. 4. ECMA International 2009. Property name. Identifier name. String literal numeric literal. Property set parameter list. Identifier. Semantics. The production object literal is evaluated as follows. Return a new object created as if by the expression new object, where object is the standard built-in constructor with that name. The production's object literal, property name and value list, and object literal, property name and value list, are evaluated as follows. Return the result of evaluating property name and value list. The production property name and value list property assignment is evaluated as follows. Let obj be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. Let prop_id be the result of evaluating property assignment. Call the internal method of obj with arguments prop_id name, prop_id descriptor, and false. Return obj. The production property name and value list. Property name and value list. Property assignment is evaluated as follows. Let obj be the result of evaluating property name and value list. Let prop_id be the result of evaluating property assignment. Let previous be the result of calling the internal method of obj with argument prop_id name. If previous is not undefined, then throw a syntax error exception if any of the following conditions are true. A. This production is contained in strict code and is data descriptor. Previous is true and is data descriptor. Prop_id descriptor is true. B is data descriptor. Previous is true and is accessor descriptor. Prop_id descriptor is true. C is accessor descriptor. Previous is true and is data descriptor. Prop_id descriptor is true. D is accessor descriptor. Previous is true and is accessor descriptor. Prop_id descriptor is true and either both previous and prop_id descriptor have. Call the internal method of obj with arguments prop_id name, prop_id descriptor, and false. Return obj. If the above steps would throw a syntax error, then an implementation must treat the error as an early error. Clause 16. The production property assignment. T. Property name Assignment expressioni servaluaterdas follows. Let prop name be the result of evaluating property name. Let exp value be the result of evaluating assignment expression. Let prop value be get value. Exp value. Let desk be the property descriptor. Prop value. True. True. Configurable. True. Return property identifier. Prop name. Desk. ECMA International 2009-65. The production property assignment. Get property name. Function body. Is evaluated as follows. Let prop name be the result of evaluating property name. Let closure be the result of creating a new function object as specified in 13.2 with an empty parameter list, and body specified by function body. Pass in the lexical environment of the running execution context as the scope. Pass in true as the strict flag if the property assignment is contained in strict code or if its function body is strict code. Let desk be the property descriptor. True. True. Return property identifier. Prop name. Desk. The production property assignment. Set property name. Property set parameter list. Function body. Is evaluated as follows. Let prop name be the result of evaluating property name. Let closure be the result of creating a new function object as specified in 13.2 with parameters specified by property set parameter list and body specified by function body. Pass in the lexical environment of the running execution context as the scope. Pass in true as the strict flag if the property assignment is contained in strict code or if its function body is strict code. Let desk be the property descriptor. True. True. Return property identifier. Prop name. Desk. It is a syntax error if the identifier eval or the identifier arguments occurs as the identifier in a property set parameter list. O, F, A, capital P, R, O, P, E, R, T, Y, capital A, S, S, I, G, N, M, E, N, T, T, H, A, T, I, S, C, O, N. The production property name. Identifier name is evaluated as follows. Return a string value containing the same sequence of characters as the identifier name. The production property name. String literal is evaluated as follows. Return the SV of the string literal. The production property name. Numeric literal is evaluated as follows. Let NBR be the result of forming the value of the numeric literal. Return to string. NBR 1, 1. 6. The grouping operator. The production primary expression is evaluated as follows. Return the result of evaluating expression. This may be of type reference. Note this algorithm does not apply get value to the result of evaluating expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. 1.2 Left-hand side expressions. Syntax. Member expression. Primary expression. Function expression. Member expression. Expression. Member expression. Identifier name. New member expression. Arguments. 6. ECMA International 2009. New expression. Member expression. New expression. Call expression. Member expression. Arguments. Call expression. Arguments. Call expression. Expression. Call expression. Identifier name. Arguments. Argument list. Argument list. Assignment expression. Argument list. Assignment expression. Left-hand side expression. New expression. Call expression. 1, 2. 1. Property accesses. Properties are accessed by name, using either the dot notation, member expression, identifier name, call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression. Identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression. Identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is a string literal containing the same sequence of characters after processing of Unicode escape sequences as the identifier name. The production member expression, expression, is evaluated as follows. Let base reference be the result of evaluating member expression. Let base value be get value. Base reference. Let property name reference be the result of evaluating expression. Let property name value be get value. Property name reference. Call check object coercible. Passive value. Let property name string be to string. Property name value. If the syntactic production that is being evaluated is contained in strict mode code, let strict be true. Else let strict be false. ECMA International 2009 67 8. Return a value of type reference whose base value is base value and whose reference name is property name string, and whose strict mode flag is strict. The production call expression is evaluated in exactly the same manner, except that the contained call expression is evaluated in step 1. 2. The new operator. The production new expression is evaluated as follows. Let ref be the result of evaluating new expression. Let constructor be get value. Ref. If type constructor is not object, throw a type error exception. If constructor does not implement the internal method, throw a type error exception. Return the result of calling the internal method on constructor, providing no arguments. That is an empty list of arguments. The production member expression, new member expression arguments is evaluated as follows. Let ref be the result of evaluating member expression. Let constructor be get value. Ref. Let arglist be the result of evaluating arguments, producing an internal list of argument values. 1 1 2 4. If type constructor is not object, throw a type error exception. If constructor though not implement the internal method, throw a type error exception. Return the result of calling the internal method on constructor, providing the list arglist as the argument values. 1 2 3 function calls. The production call expression, member expression arguments is evaluated as follows. Let ref be the result of evaluating member expression. Let fun be get value. Ref. Let arglist be the result of evaluating arguments, producing an internal list of argument values. C1 1 2 4. If type func is not object, throw a type error exception. If is callable func is false, throw a type error exception. If type ref is reference, then if is property reference ref is true, then I let this value be get base ref be else. The base of ref is an environment record. I let this value be the result of calling the implicit this value concrete method of get base ref 7. Else type ref is not reference. I let this value be undefined. Return the result of calling the internal method on func, providing this value as the this value and providing the list arglist as the argument values. The production call expression arguments is evaluated in exactly the same manner, except that the contained call expression is evaluated in step 1. Note the returned result will never be of type reference if func is a native ECMAScript object. Whether calling a host object can return a value of type reference is implementation dependent. If a value of type reference is returned, it must be a non-strict property reference. 1 2 4 argument lists. The evaluation of an argument list produces a list of values. C 8.8. The production arguments is evaluated as follows. 8. Copyright sign. ECMA International 2009. 1. Return an empty list. The production argument list is evaluated as follows. Return the result of evaluating argument list. The production argument list assignment expression is evaluated as follows. Let ref be the result of evaluating assignment expression. Let arg be get value. Ref. Return a list whose sole item is arg. The production argument list assignment expression is evaluated as follows. Let preceding args be the result of evaluating argument list. Let ref be the result of evaluating assignment expression. Let arg be get value. Ref. Return a list whose length is 1 greater than the length of preceding args and whose items are the items of preceding args, in order, followed at the end by arg which is the last item of the new list. 1 2 5 function expressions. The production member expression function expression is evaluated as follows. 1. Return the result of evaluating function expression. 1.3 postfix expression syntax. Postfix expression, left-hand side expression, no line terminator here, plus plus left-hand side expression, no line terminator here. 1, 3, 1 postfix increment operator. The production postfix expression, left-hand side expression, no line terminator here, plus plus is evaluated as follows. Let LHS be the result of evaluating left-hand side expression. Throw a syntax error exception if the following conditions are all true. Type LHS is references true, is strict reference, LHS is true. Type get base, LHS is environment record. Get reference name, LHS is either eval or arguments. Let old value be to number, get value, LHS. Let new value be the result of adding the value 1 to old value, using the same rules as for the plus operator. C, 1, 6, 3. Call put value, LHS, new value. Return old value, 1, 3, 2. Postfix decrement operator. The production postfix expression, left-hand side expression, no line terminator here, is evaluated as follows. Let LHS be the result of evaluating left-hand side expression. Throw a syntax error exception if the following conditions are all true. Type LHS is references true. ECMA International 2009 69. Is strict reference. LHS is true. Type get base. LHS is environment record. Get reference name. LHS is either eval or arguments. Let old value be to number, get value, LHS. Let new value be the result of subtracting the value 1 from old value, using the same rules as for the operator. 1, 1, 6, 3. Call put value, LHS, new value. Return old value. 1.4 Unary operators syntax. Unary expression. Postfix expression, delete unary expression, void unary expression, type of unary expression plus plus unary expression plus unary expression, unary expression, unary expression, unary expression. 1, 4, 1/3 delete operator. The production unary expression, delete unary expression is evaluated as follows. Let ref be the result of evaluating unary expression. If type ref is not reference, return true. If is unresolvable reference, ref, then if is strict reference, ref, is true. Throw a syntax error exception. Be else, return true. If is property reference, ref, is true, then a return the result of calling the internal method onto object, get base, ref, providing get reference name, ref, and is strict reference, ref, as the arguments. Else, ref is a reference to an environment record binding. So, ABC. Note, unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, a type error exception is thrown. 1, 4, 2. Avoid operator. The production unary expression, void unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Call get value, expressway. Return undefined. Note get value must be called even though its value is not used because it may have observable side effects. If is strict reference, ref, is true, throw a syntax error exception. Let bindings be get base, ref. Return the result of calling the delete binding concrete method of bindings, providing get reference name, ref, as the argument. When a delete operator occurs within strict mode code, a syntax error exception is thrown if it's 0, copyright sign, ECMA International 2009, 11, 4, 3. The tipioff operator. The production unary expression, type of unary expression is evaluated as follows. Let val be the result of evaluating unary expression. If type val is reference, then if is unresolvable reference, val is true, return undefined. B. Let val be get value, val. Return a string determined by type val, according to table 20. Table 20. Type of operator results. Type of val undefined. Null boolean number string. Object native and does not implement. Object native or host and does implement. Object host and does not implement. Result undefined. Object boolean number string. Object function implementation defined except may not be undefined. Boolean number or string. 1, 1, 4. 4 prefix increment operator. The production unary expression plus unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Throw a syntax error exception if the following conditions are all true. Type expa is references true is strict reference. Expa is true. Type get base. Expa is environment record. Get reference name. Expa is either eval or arguments. Let old value be to number. Get value. Expa. Let new value be the result of adding the value 1 to old value, using the same rules as for the plus operator. C. 1. 6. 3. Call put value. Expressway. New value. Return new value. 1. 4. 5 prefix decrement operator. The production unary expression. Unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Throw a syntax error exception if the following conditions are all true. Type expa is references true is strict reference. Expa is true. Type get base. Expa is environment record. Get reference name. Expa is either eval or arguments. Let old value be to number. Get value. Expa. ECMA International 2009 71. 4. Let new value be the result of subtracting the value 1 from old value, using the same rules as for the operator. C11. 6. 3. Call put value. Expressway. New value. Return new value. 1. 4. 6 unary plus operator. The unary plus operator converts its operand to number type. The production unary expression plus unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Return to number. Get value. Expa. 1. 4. 7 unary operator. The unary operator converts its operand to number type and then negates it. Note that negating plus 0 produces 0, and negating 0 produces plus 0. The production unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Let old value be to number. Get value. Expa. If old value is nan, return nan. Return the result of negating old value. That is, compute a number with the same magnitude but opposite sign. 1. 4. 8 bitwise not operator. The production unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Let old value be 32. Get value. Expa. Return the result of applying bitwise complement to old value. The result is a signed 32-bit integer. 1. 4. 9 logical not operator. The production unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Let old value be to boolean. Get value. Expa. If old value is true, return false. Return true. 1.5 multiplicative operators syntax. Multiplicative expression. Unary expression. Multiplicative expression. Unary expression. Multiplicative expression. Unary expression. Multiplicative expression. Percent. Unary expression. Semantics. The production multiplicative expression at unary expression, where at stands for one of the operators in the above definitions, is evaluated as follows. 2. Copyright sign. ECMA International 2009. 1. Let left be the result of evaluating multiplicative expression. Let left value be get value. Left. Let right be the result of evaluating unary expression. Let right value be get value. Right. Let left num be to number. Left value. Let right num be to number. Right value. Return the result of applying the specified operation, comma or percent, to left num and right num. See the notes below. 1 1 5 1 1 1 5 2 1 1 5 3 1 5 1. Applying the operator. The operator performs multiplication, producing the product of its operands. Multiplication is commutative. Multiplication is not always associative in ECMAScript. Because of finite precision, the result of a floating point multiplication is governed by the rules of IEEE 754 binary double precision arithmetic. If either operand is nan, the result is nan. The sign of the result is positive if both operands have the same sign. Negative if the operands have different signs. Multiplication of an infinity by a 0 results in an. Multiplication of an infinity by an infinity results in an infinity. The sign is determined by the rule already stated above. Multiplication of an infinity by a finite non-zero value results in a signed infinity. The sign is determined by the rule already stated above. In the remaining cases, where neither an infinity or none is involved, the product is computed and rounded to the nearest representable value using IEEE 754 round to nearest mode. If the magnitude is too large to represent, the result is then an infinity of appropriate sign. If the magnitude is too small to represent, the result is then a 0 of appropriate sign. The ECMAScript language requires support of gradual underflow as defined by IEEE 754 1.5. To applying the operator performs division, producing the quotient of its operands. The left operand is the dividend and the right operand is the divisor. ECMAScript does not perform integer division. The operands and result of all division operations are double precision floating point numbers. The result of division is determined by the specification of IEEE 754 arithmetic. If either operand is nan, the result is nan. The sign of the result is positive if both operands have the same sign. Negative if the operands have different signs. Division of an infinity by an infinity results in nan. Division of an infinity by a 0 results in an infinity. The sign is determined by the rule already stated above. Division of an infinity by a non-zero finite value results in a signed infinity. The sign is determined by the rule already stated above. Division of a finite value by an infinity results in 0. The sign is determined by the rule already stated above. Division of a 0 by a 0 results in nan. Division of 0 by any other finite value results in 0. With the sign determined by the rule already stated above. Division of a non-zero finite value by a 0 results in a signed infinity. The sign is determined by the rule already stated above. In the remaining cases, where neither an infinity, nor 0, nor nan is involved, the quotient is computed and rounded to the nearest representable value using IEEE 754 round to nearest mode. If the magnitude is too large to represent, the operation overflows. The result is then an infinity of appropriate sign. If the magnitude is too small to represent, the ECMA International 2009-73 operation underflows and the result is a 0 of the appropriate sign. The ECMAScript language requires support of gradual underflow as defined by IEEE 754 1.5. 3. Applying the percent operator. The percent operator yields the remainder of its operands from an implied division. The left operand is the dividend, and the right operand is the divisor. Note, in C and C++, the remainder operator accepts only integral operands. In ECMAScript, it also accepts floating point operands. The result of a floating point remainder operation as computed by the percent operator is not the same as the remainder operation defined by IEEE 754. The IEEE 754 remainder operation computes the remainder from a rounding division, not a truncating division, and so its behavior is not analogous to that of the usual integer remainder operator. Instead, the ECMAScript language defines percent on floating point operations to behave in a manner analogous to that of the Java integer remainder operator. This may be compared with the C library function fmod. The result of an ECMAScript floating point remainder operation is determined by the rules of IEEE arithmetic. If either operand is nan, the result is nan. The sign of the result equals the sign of the dividend. If the dividend is an infinity, or the divisor is a 0, or both, the result is nan. If the dividend is finite and the divisor is an infinity, the result equals the dividend. If the dividend is a 0 and the divisor is finite, the result is t, same as the dividend. In the remaining cases, where neither an infinity, nor 0, nor nan is involved, the floating point remainder r from a dividend n and a divisor d is defined by the mathematical relation r equals n dq, where q is an integer that is negative only if nd is negative and positive only if nd is positive, and whose magnitude is as large as possible without exceeding the magnitude of the true mathematical quotient of n and d. 1.6 Additive operators syntax. Additive expression, multiplicative expression, additive expression plus multiplicative expression, additive expression, multiplicative expression. 1. 6. 1. The addition operator, plus. The addition operator either performs string concatenation or numeric addition. The production additive expression plus multiplicative expression is evaluated as follows. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let ref be the result of evaluating multiplicative expression. Let val be get value. Ref. Let prim be to primitive. Val. Let reprim be to primitive. Reval. If type prim is string or type reprim is string, then return the string that is the result of concatenating to string prim followed by to string reprim. 8. Return the result of applying the addition operation to number prim and to number reprim. See the note below 1.1.6.3. Note 1. No hint is provided in the calls to primitive in steps 5 and 6. All native ECMAScript objects except date objects handle the absence of a hint as if the hint number were given. Date objects handle the absence of a hint as if the hint string were given. Host objects may handle the absence of a hint in some other manner. 4. Copyright sign. ECMA International 2009. Note 2. Step 7 differs from Step 3 of the comparison algorithm for the relational operators 1.1.8.5 by using the logical or operation instead of the logical and operation 1.6 to the subtraction operator. The production additive expression, multiplicative expression is evaluated as follows. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let ref be the result of evaluating multiplicative expression. Let val be get value. Ref. Let num be to number. Val. Let renum be to number. Reval. Return the result of applying the subtraction operation till num and renum. See the note below 1.1.6.3. 1.6.3. Applying the additive operators to numbers. The plus operator performs addition when applied to two operands of numeric type, producing the sum of the operands. The operator performs subtraction, producing the difference of two numeric operands. Addition is a commutative operation, but not always associative. The result of an addition is determined using the rules of IEEE 754 binary double precision arithmetic. If either operand is nan, the result is nan. The sum of two infinities of opposite sign is nan. The sum of two infinities of the same sign is the infinity of that sign. The sum of an infinity and a finite value is equal to the infinite operand. The sum of two negative zeros is 0. The sum of two positive zeros, or of two zeros of opposite sign, is plus 0. The sum of a 0 and a non-zero finite value is equal to the non-zero operand. The sum of two non-zero finite values of the same magnitude and opposite sign is plus 0. In the remaining cases, where neither an infinity, nor a 0, nor nan is involved, and the operands have the same sign or have different magnitudes, the sum is computed and rounded to the nearest representable value using IEEE 754 round 2. Nearest mode. If the magnitude is too large to represent, the operation overflows and the result is then an infinity of appropriate sign. The ECMAScript language requires support of gradual underflow as defined by IEEE 754. The operator performs subtraction when applied to two operands of numeric type, producing the difference of its operands. The left operand is the minuend and the right operand is the subtrahend. Given numeric operands A and B, it is always the case that AB produces the same result as A plus B. 1.7 bitwise shift operators syntax. Shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression. 1.7. 1. The left shift operator performs a bitwise left shift operation on the left operand by the amount specified by the right operand. ECMA International 2009 75. The production shift expression, additive expression is evaluated as follows. Let ref be the result of evaluating shift expression. Let val be get value. Ref. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let num be 32. Val. Let renum be 32. Reval. Let shift count be the result of masking out all but the least significant 5 bits of renum. That is, compute renum 0 times 1f. Return the result of left shifting num by shift count bits. The result is a signed 32-bit integer 1, 7. To the signed right shift operator performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. The production shift expression additive expression is evaluated as follows. Let ref be the result of evaluating shift expression. Let val be get value. Ref. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let num be 32. Val. Let renum be 32. Reval. Let shift count be the result of masking out all but the least significant 5 bits of renum. That is, compute renum 0 times 1f. Return the result of performing a sign extending right shift of num by shift count bits. The most significant bit is propagated. The result is a signed 32-bit integer 1, 7. 3. The unsigned right shift operator performs a 0 filling bitwise right shift operation on the left operand by the amount specified by the right operand. The production shift expression additive expression is evaluated as follows. Let ref be the result of evaluating shift expression. Let val be get value. Ref. Let ref be the result of evaluating additive expression. Let reval be get value. Ref. Let num be 32. Val. Let renum be 32. Reval. Let shift count be the result of masking out all but the least significant 5 bits of renum. That is, compute renum 0 times 1f. Return the result of performing a 0 filling right shift of num by shift count bits. Vacated bits are filled with 0. The result is an unsigned 32-bit integer 6. ECMA International 2009 11.8 Relational operators syntax. Relational expression. Shift expression. Relational expression. Shift expression. Relational expression. Shift expression. Relational expression equals shift expression. Relational expression equals shift expression. Relational expression instance of shift expression. Relational expression in shift expression. Relational expression known. Shift expression. Relational expression known. Shift expression. Relational expression known. Shift expression. Relational expression known equals shift expression. Relational expression known equals shift expression. Relational expression known instance of shift expression. The result of evaluating a relational operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. The relational expression known productions are evaluated in the same manner as the relational expression productions, except that the contained relational expression known is evaluated instead of the contained relational expression. 1. 8. 1. The less than operator. The production relational expression shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. Let r be the result of performing abstract relational comparison. Val. Reval. C11 8 5. If r is undefined, return false. Otherwise, return r1 8 to the greater than operator. The production relational expression shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. Let r be the result of performing abstract relational comparison. Reval. Val with left first equal to false. C11 8 5. If r is undefined, return false. Otherwise, return r. The no invariants are needed to avoid confusing the in operator in a relational expression with the in semantics. Note: operator in a for statement. ECMA International 2009 77 11 8 3. The less than or equal operator equals the production relational relational expression equals shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. Let ref the result of performing abstract relational comparison. Reval. Val with left first equal to false. C11 8 5. If r is true or undefined, return false. Otherwise, return true. 1 8 for the greater than or equal operator. equals the production relational expression equals shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let val be get value. Ref. Let r be the result of performing abstract relational comparison. Val. Reval. C11, 8, 5. If r is true or undefined, return false. Otherwise, return true. 1, 8, 5. The abstract relational comparison algorithm, the comparison x, y, where x and y are values, produces true, false, or undefined, which indicates that at least one operand is nan. In addition to x and y, the algorithm takes a Boolean flag named left first as a parameter. The flag is used to control the order in which operations with potentially visible side effects are performed upon x and y. It is necessary because ECMAScript specifies left to right evaluation of expressions. The default value of left first is true and indicates that the x parameter corresponds to an expression that occurs to the left of the y parameter's corresponding expression. If left first is false, the reverse is the case and operations must be performed upon y before x. Such a comparison is performed as follows. If the left first flag is true, then a let px be the result of calling to primitive x, hint number. B let pi be the result of calling to primitive y, hint number. Else the order of evaluation needs to be reversed to preserve left to right evaluation. A let pi be the result of calling to primitive y, hint number. B let px be the result of calling to primitive x, hint number. Iphitis. A let nx be the result of calling to number px. Because px and pi are primitive values evaluation, not the case that both type px is string and type pi is string, then order is not important. B let ni be the result of calling to number pi. C if nx is nan, return undefined. D if ni is nan, return undefined. E if nx and ni are the same number value, return false. F if nx is plus 0 and ni is 0, return false. G if nx is 0 and ni is plus 0, return false. H if nx is plus, return false. I if ni is plus, return true. J if ni is, return false. K if nx is, return true. L if the mathematical value of nx is less than the mathematical value of ni. Note that these mathematical values are both finite and not both 0, return true. Otherwise, return false. Else, both px and pi are strings. If pi is a prefix of px, return false. A string value p is a prefix of string value q. If q can be the result of concatenating p and some other string, note that any string is a prefix of itself, because r may be the empty string. 8. ECMA International 2009. B if px is a prefix of pi, return true. C let k be the smallest non-negative integer such that the character at position k within px is different from the character at position k within pi. There must be such a k, for neither string is a prefix of the other. D let m be the integer that is the code unit value for the character at position k within px. E let n be the integer that is the code unit value for the character at position k within pi. F if m, n, return true. Otherwise, return false. Step 3 differs from step 7 in the algorithm for the addition operator plus 1 1, 6, 1. In using and instead of or. Note 2. Attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, string values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. Also, note that for strings containing supplementary characters, lexicographic ordering on sequences of UTF-16 code unit values differs from that on sequences of code point values. 1, 8, 6. The instantiaf operator, the production relational expression instantiaf shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. If type reval is not object, throw a type error exception. If reval does not have an internal method, throw a type error exception. Return the result of calling the internal method of reval with argument val. 1, 8, 7. The operator. The production relational expression in shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. If type reval is not object, throw a type error exception. Return the result of calling the internal method of reval with argument to string. Val. 1.9 Equality operators syntax. Equality expression, relational expression. Equality expression equals 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 relational expression. Equality expression known, relational expression known. Equality expression known equals 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 relational expression known. Note 1. The comparison of strings uses a simple lexicographic ordering on sequences of code unit values. There is no ECMA International 2009-79 semantics. The result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. The equality expression known productions are evaluated in the same manner as the equality expression productions, except that the contained equality expression known and relational expression known are evaluated instead of the contained equality expression and relational expression, respectively. 1. 9. 1. The equals operator equals. The production equality expression equals relational expression is evaluated as follows. Let ref be the result of evaluating equality expression. Let val be get value. Ref. Let ref be the result of evaluating relational expression. Let reval be get value. Ref. Return the result of performing abstract equality comparison. Reval equals leval. C11 9 3 1 9 to the does not equals operator equals. The production equality expression equals relational expression is evaluated as follows. Let ref be the result of evaluating equality expression. Let val be get value. Ref. Let ref be the result of evaluating relational expression. Let reval be get value. Ref. Let r be the result of performing abstract equality comparison. Reval equals leval. C11 9 3. If r is true, return false. Otherwise, return true. 1 9 3. The abstract equality comparison algorithm. The comparison x equals y, where x and y are values, produces true or false. Such a comparison is performed as follows. If type x is the same as type y, then if type x is undefined, return true. B if type x is null, return true. C if type x is number, then if x is nan, return false. 2. If y is nan, return false. 3. If x is the same number value as y, return true. If x is plus 0 and y is 0, return true. V. If x is 0 and y is plus 0, return true. V. Return false. D. If type x is string, then return true if x and y are exactly the same sequence of characters, same length and same characters in corresponding positions. Otherwise, return false. E. If type x is Boolean, return true if x and y are both true or both false. Otherwise, return false. F. Return true if x and y refer to the same object. Otherwise, return false. I. If x is null and y is undefined, return true. I. If x is undefined and y is null, return true. If type x is number and type y is string, return the result of the comparison x equals to number y. If type x is string and type y is number, return the result of the comparison to number x equals y. If type x is Boolean, return the result of the comparison to number x equals y. If type y is Boolean, return the result of the comparison x equals to number y. If type x is either string or number and type y is object, 0. ECMA International 2009. Return the result of the comparison x equals to primitive var y 9. If type x is object and type y is either string or number, return the result of the comparison to primitive x equals y. 0. Return false. Note 1. Note 2, comma, given the above definition of equality, string comparison can be forced by plus a equals plus b. Numeric comparison can be forced by plus a equals plus b. Boolean comparison can be forced by a equals b. The equality operators maintain the following invariants: a equals bis equivalento, a equals b, a equals bis equivalento, b equals a, except in the order of evolution or found. Note 3. Representing the same string value, each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. The equality operator is not always transitive. For example, there might be two distinct string objects, each. Note: for comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 1. 9. For the strict equals operator, equals. The production equality expression equals relational expression is evaluated as follows. Let ref be the result of evaluating equality expression. Let val be get value. Ref. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Return the result of performing the strict equality comparison. Reval equals val. C11 9 6 1 9 5. The strict does not equal operator equals. The production equality expression equals relational expression is evaluated as follows. Let ref be the result of evaluating equality expression. Let val be get value. Ref. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let r be the result of performing strict equality comparison. Reval equals val. C11 9 6. If r is true, return false. Otherwise, return true. 1 9 6. The strict equality comparison algorithm, the comparison x equals y, where x and y are values, produces true or false. Such a comparison is performed as follows. If type x is different from type y, return false. If type x is undefined, return true. If type x is null, return true. If type x is number, then A if x is nan, return false. B if y is nan, return false. C if x is the same number value as y, return true. D if x is plus 0 and I is 0, return true. E if x is 0 and I is plus 0, return true. F return false. ECMA International 2009 81 5. If type x is string, then return true if x and y are exactly the same sequence of characters, same length and same characters in corresponding positions. Otherwise, return false. If type x is Boolean, return true if x and y are both true or both false. Otherwise, return false. Return true if x and y refer to the same object. Otherwise, return false. Note this algorithm differs from the same value algorithm 9.12 in its treatment of sign zeros and nans. 1.10 binary bitwise operators syntax. Bitwise and expression, equality expression. Bitwise and expression and equality expression. Bitwise and expression known, equality expression known. Bitwise and expression known and equality expression known. Bitwise or expression. Bitwise and expression. Bitwise or expression. Bitwise and expression. Bitwise or expression known. Bitwise and expression known. Bitwise or expression known. Bitwise and expression known. Bitwise or expression. Bitwise or expression. Bitwise or expression. Bitwise or expression. Bitwise or expression known. bitwise or expression known, bitwise or expression known, bitwise or expression known semantics. The production A, at B, where at is one of the bitwise operators in the productions above, is evaluated as follows. Let return the result of applying the bitwise operator at lnum and renum. The result is a signed 32-bit integer, 1.11 binary logical operators syntax, logical and expression, bitwise or expression, logical and expression and bitwise or expression, logical and expression known, bitwise or expression known, logical and expression known and bitwise or expression known. 2. ECMA International 2009. Ref be the result of evaluating lval b get value. Ref be the result of evaluating b reval b get value. Ref lnum b twint 32, lval renum b twint 32. Reval logical or expression, logical and expression, logical or expression, logical and expression, logical or expression known, logical and expression known, logical or expression known, logical and expression known semantics. The production logical and expression and bitwise or expression is evaluated as follows. Let ref be the result of evaluating logical and expression. Let lval be get value. Ref if to boolean lval is false, return lval. Let ref be the result of evaluating bitwise or expression. Return get value. Ref the production logical or expression logical and expression is evaluated as follows. Let ref be the result of evaluating logical or expression. Let lval be get value. Ref if to boolean lval is true, return lval. Let ref be the result of evaluating logical and expression. Return get value. Ref the logical and expression known and logical or expression known productions are evaluated in the same manner as the logical and logical or expression productions, except that the contained logical and expression known, bitwise or expression known and logical or expression known are evaluated instead of the contained logical and expression, bitwise or expression and logical or expression, respectively. Note the value produced by a and or operator is not necessarily of type Boolean. The value produced will always be the value of one of the two operand expressions. 1.12 Conditional operator. Syntax. Conditional expression. Logical or expression. Logical or expression. Assignment expression. Assignment expression. Conditional expression known. Logical or expression known. Logical or expression known. Assignment expression. Assignment expression known semantics. The production conditional expression. Logical or expression. Assignment expression. Assignment expression is evaluated as follows. Let ref be the result of evaluating logical or expression. If to boolean get value ref is true, then a let true ref be the result of evaluating the first assignment expression. B return get value true ref. Else a let false ref be the result of evaluating the second assignment expression. B return get value false ref. ECMA International 2009-83. The conditional expression known production is evaluated in the same manner as the conditional expression production, except that the contained logical or expression known, assignment expression and assignment expression known are evaluated instead of the contained logical or expression, first assignment expression and second assignment expression, respectively. Note the grammar for a conditional expression in ECMAScript is a little bit different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMAScript is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. 1.13 Assignment operators syntax. Assignment expression. Conditional expression. Left-hand side expression. Assignment operator. Assignment expression. Assignment expression known. Conditional expression known. Left-hand side expression. Assignment operator. Assignment expression known. Assignment operator. One of equals percent equals plus equals and equals. Semantics. The assignment expression known productions are evaluated in the same manner as the assignment expression productions, except that the contained conditional expression known and assignment expression known are evaluated instead of the contained conditional expression and assignment expression, respectively. 1. 13, one simple assignment, equals the production assignment expression, left-hand side expression equals assignment expression is evaluated as follows. Let ref be the result of evaluating left-hand side expression. Let ref be the result of evaluating assignment expression. Let reval be get value. Ref. Throw a syntax error exception if the following conditions are all true. Type ref. Is references true? Is strict reference ref is true. Type get base ref. Is environment record. Get reference name ref. Is either eval or arguments. Call put value ref. Reval. Return reval. Note when an assignment occurs within strict mode code, its left-hand side must not evaluate to an unresolvable reference. If it does, a reference error or exception is thrown upon assignment. The left-hand side also may not be a reference to a data property with the attribute value false, to an accessor property with the attribute value internal property has the value false. In these cases, a type error exception is thrown. 1.13, 2 compound assignment. Op equals the production assignment expression, left-hand side expression at equals assignment expression, where at represents one of the operators indicated above, is evaluated as follows. 4. Copyright sign, ECMA International 2009. 1. Let ref be the result of evaluating left-hand side expression. Let val be get value ref. Let ref be the result of evaluating assignment expression. Let reval be get value ref. Let r be the result of applying operator at val and reval. Throw a syntax error exception if the following conditions are all true. Type ref. Is references true? Is strict reference ref is true. Type get base ref. Is environment record. Get reference name ref. Is either eval or arguments. Call put value ref. R. Return R. Note C note 1113 1.14 comma operator. Syntax. Expression. Assignment expression. Expression. Assignment expression. Expression known. Assignment expression known. Expression known. Assignment expression known. Semantics. The production expression. Expression. Assignment expression is evaluated as follows. Let ref be the result of evaluating expression. Call get value ref. Let ref be the result of evaluating assignment expression. Return get value ref. The expression known production is evaluated in the same manner as the expression production, except that the contained expression known and assignment expression known are evaluated instead of the contained expression and assignment expression, respectively. Note get value must be called even though its value is not used because it may have observable side effects. ECMA International 2009 85. 12 statements. Syntax. Statement. Block. Variable statement, empty statement, expression statement, if statement, iteration statement, continue statement, break statement, return statement, with statement, labeled statement, switch statement, throw statement, try statement, debugger statement. Semantics. A statement can be part of a labeled statement, which itself can be part of a labeled statement, and so on. The labels introduced this way are collectively referred to as the current label set when describing the semantics of individual statements. A labeled statement has no semantic meaning other than the introduction of a label to a label set. The label set of an iteration statement or a switch statement initially contains the single element empty. The label set of any other statement is initially empty. Note several widely used implementations of ECMAScript are known to support the use of function declaration as a statement. However, there are significant and irreconcilable variations among the implementations and the semantics applied to such function declarations. Because of these irreconcilable difference, the use of a function declaration as a statement results in code that is not reliably portable among implementations. It is recommended that ECMAScript implementations either disallow this usage of function declaration or issue a warning when such a usage is encountered. Future editions of ECMAScript may define alternative portable means for declaring functions in a statement context. 2.1 Block syntax. Block. Statement list. Opt. Statement list. Statement. Statement list. Statement. Semantics. The production block is evaluated as follows. Return normal. Empty. Empty. The production block statement list is evaluated as follows. 1. Return the result of evaluating statement list. The production statement list statement is evaluated as follows. 6. Copyright sign, ECMA International 2009. 1. Let S be the result of evaluating statement. If an exception was thrown, return, throw, V, empty, where V is the exception. Execution now proceeds as if no exception were thrown. Return S. The production statement list statement is evaluated as follows. Let SL be the result of evaluating statement list. If SL is an abrupt completion, return SL. Let S be the result of evaluating statement. If an exception was thrown, return, throw, V, empty, where V is the exception. Execution now proceeds as if no exception were thrown. If S value is empty, let V equals SL value. Otherwise let V equals S value. Return S type, V, S target. 2.2 Variable statement syntax. Variable statement. R variable declaration list. Variable declaration list. V variable declaration. Variable declaration list. Variable declaration. Variable declaration list known. V variable declaration known. Variable declaration list known. Variable declaration known. Variable declaration. Identifier initializer opt variable declaration known. Identifier initializer known. Opt initializer. Assignment expression initializer known. Assignment expression known. A variable statement declares variables that are created as defined in 10.5. Variables are initialized to undefined when created. A variable with an initializer is assigned the value of its assignment expression when the variable statement is executed, not when the variable is created. Semantics. The production variable statement, var variable declaration list, is evaluated as follows. Evaluate variable declaration list. Return normal, empty, empty. The production variable declaration list. Variable declaration is evaluated as follows. Evaluate variable declaration. find in 1 2 9 3. Literal, string literal. Return the SV of string literal as defined in 1 2 9 4 2 46. ECMA International 2024 1 3 2 4. Array initializer. Array elements may be elided at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal. Yield. Await. Elision ought. Element list yield await. Element list yield await. Elision ought. Element list. Yield. Await. Elision ought assignment expression. Plus in yield await. Elision ought spread element yield await. Element list yield await. Elision ought assignment expression. Plus in yield await. Element list yield await. Elision ought spread element yield await. Elision. Spread element. Yield. Await. Dot. Assignment expression. Plus in yield await. 1 3 2 4 1. Runtime semantics. Array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note. The above step throws if len exceeds 232. 1. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision ought assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x init value. Return next index plus 1. Note an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision ought spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision ought assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x init value. Return next index plus 1. Element list. Elision ought spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return next index. See perform. Create data property or throw array to string next int x next d set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3 2 4 2. Runtime semantics. Evaluation. Array literal. Elision ought. Let array be. Array create. 0. If elision is present, then a perform. Array accumulation of elision with arguments array in 0. 3. Return array. Array literal. Element list. Let array be. Array create. 0. Perform. Array accumulation of element list with arguments array in 0. Return array. Array literal. Element list. Elision ought. 2. Let array be. Array create. 0. Let next index be. Array accumulation of element list with arguments array in 0. 48. ECMA International 2024. 3. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3. 2. 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dot. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In. Yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign. ECMA International 2024 249. Note 3 in certain contexts. Object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N or capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least 2 of those entries were obtained from productions of the form property definition, property name, assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax-directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, literal property name, return false, property name, computed property name, return true. Addition to describing an actual object initializer, the object literal productions are also 250. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3. Static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5, 4. Runtime semantics. Evaluation. Object literal. Return ordinary object create. Object prototype object literal property definition list property definition list. Let obj be ordinary object create object prototype perform property definition evaluation of property definition list with argument obj. Return obj literal property name identifier name. Return string value of identifier name literal property name string literal 1. Return the SV of string literal property name, numeric literal. Let NBR be the numeric value of numeric literal. Return to string, NBR, computed property name, assignment expression. Let exp value be evaluation of assignment expression. Let prop name be get value, exp value. Return to property key, prop name. 3, 2, 5. Runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition. Perform. Property definition evaluation of property definition list with argument object. Perform. Property definition evaluation of property definition with argument object. Return unused. ECMA International 2024 251. Property definition. Assignment expression. Let exp value be evaluation of assignment expression. Let from value be get value, exp value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value. Excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let exp value be evaluation of identifier reference. Let prop value be get value, exp value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw object, prop name, prop value. Return unused. Property definition. Property name. Assignment expression. Let prop key be evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse. Then, a let is proto set to be false. Else if prop key is proto and is computed property key of property name is false, then a let is protosetter be true, else a let is protosetter be false. If is anonymous function definition, assignment expression, is true and is protosetter is false, then a let proper value be. Named evaluation of assignment expression with argument prop key, else a let exp value ref be. Capital E evaluation of assignment expression be let proper value be. Get value, exp value ref. If is protosetter is true, then if proper value is an object or proper value is null, then I perform object, prop value be return unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw, object, prop key, proper value 0. Return unused. Property definition, method definition. Perform. Method definition evaluation of method definition with arguments, object and true. Return unused. 3, 2, 6 function defining expressions. See 15.2 for primary expression. Function expression. See 15.5 for primary expression. Generator expression. See 15.7 for primary expression. Class expression. See 15.8 for primary expression. Async function expression. See 15.6 for primary expression. Async generator expression. 52. Copyright sign. ECMA International 2024. 132. 7 regular expression literals syntax. C12. 9. 5. 3. 2. 7. 1 static semantics. Early errors. Primary expression. Regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2 static semantics, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal. If U is false and V is false, then a let string value be code points to string, pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern, pattern text, U, V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics, evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of regular expression literal. Return. regexp create, pattern, flags. 3, 2, 8 template literals syntax. Template literal, yield, await, tagged, no substitution template. Substitution template yield await tagged. Substitution template, yield, await, tagged, template head expression, plus in yield await. Template spans yield await tagged. Template spans, yield, await, tagged, template tail. Template middle list yield await tagged, template tail. ECMA International 2024 253. Template middle list, yield, await, tag ed, template middle expression, plus in yield await. Template middle list yield await tagged, template middle expression, plus in yield await. 3, 2, 8, 1 static semantics, early errors. Template literal, yield, await, tagged, no substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence. Template literal, yield, await, tagged, substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument false is greater than or equal to 232. Substitution template, yield, await, tagged, template head expression, plus in yield await, template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans, yield, await, tagged, template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list, yield, await, tagged, template middle expression, plus in yield await, template middle list yield await tagged, template middle expression, plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, just static semantics, template strings. The syntax directed operation template strings takes argument draw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template, raw. Substitution template, template head expression template spans. Let head be template string, template head, raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans, template tail. Return template string, template tail, raw. Template spans, template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string, template tail, raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression 1. Return template string, template middle, raw. Template middle list, template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string, template middle, raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics, template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token, else a let string be the TV of template token. Return string. 3, 2, 8, 4 get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0, 2. Repeat. While int x, count a let prop b. To string, index b let cooked value be cooked strings, index c perform. Define property or throw, template, prop, property descriptor, cooked value, writable, false, true, false. D let raw value be the string value raw strings, index e perform. Define property or throw, raw obj, prop, property descriptor, raw value, false, true, false. F set index index plus 1, 3. Perform. Set integrity level, raw obj, frozen, 4. Perform. Define property or throw, template, raw, property descriptor, raw obj, false, enumerable, false, false. 5. Perform. Set integrity level, template, frozen, 6. Append the record, template literal, template, to realm, 7. Return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1, 3, 2, 8, 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 1, 3, 2, 8, 5. Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitutio. An evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let precede in be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3, 2, 8, 6. Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1, 2, 9, 6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value are like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1, 2, 9, 6. Template spans. Template middle list. Template tail. Let head be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1, 2, 9, 6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. get value, subref, let last be. To string, sub, return the string concatenation of rest, middle, and last. 3, 2, 9 the grouping operator. 3, 2, 9, 1 static semantics, early errors, primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, must cover a parenthesized expression. 3, 2, 9. To runtime semantics, evaluation, primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let expa be the parenthesized expression that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return. Evaluation of expa, parenthesized expression, expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type-off may be applied to parenthesized expressions. ECMA International 2024 257 13.3 left-hand side expressions syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await, plus tagged super property yield await, meter property, new member expression yield await, arguments yield await, member expression yield await, private identifier super property, yield await, super expression, plus in yield await, super identifier name meter property, new target, import meter, new target, import meter, import meta, new expression, yield, await, member expression yield await, new expression yield await, call expression, yield, await, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, super call yield await, import call yield await, call expression yield await, arguments yield await, call expression yield await, expression, plus in yield await, call expression yield await. Identifier name, call expression yield await, template literal yield await, plus tagged, call expression yield await. Private identifier, super call, yield, await, super arguments yield await, import call, yield, await, import, assignment expression, plus and yield await. Arguments, yield, await. Argument list yield await. Argument list yield await. 58. ECMA International 2024. Argument list, yield, await, assignment expression, plus and yield await. Dart. Assignment expression, plus and yield await. Argument list yield await. Assignment expression, plus and yield await. Argument list yield await. Assignment expression, plus and yield await. Optional expression, yield, await. Member expression yield await. Optional chain yield await. Call expression yield await. Optional chain yield await. Optional expression yield await. Optional chain yield await. Optional chain, yield, await. Arguments yield await. Expression, plus and yield. Identifier name, template literal yield await, plus tagged. Private identifier, optional chain yield await. Arguments yield await. Optional chain yield await. Expression, plus and yield await. Optional chain yield await. Identifier name, optional chain yield await. Template literal yield await, plus tagged. Optional chain yield await. Private identifier, left-hand side expression, yield, await. New expression yield await. Call expression yield await. Optional expression yield await. Supplemental syntax. When processing an instance of the production, call expression, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. The interpretation of capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, is refined using the following grammar. Call member expression, yield, await. Member expression yield await. Arguments yield await. 3, 3, 1 static semantics. 3, 3, 1, 1 static semantics. Early errors. Optional chain. Template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code. A, B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining. A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meta. Import meta. It is a syntax error if the syntactic goal symbol is not module 1.3.3. 2 property accesses. Note properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3, 3, 2, 1 runtime semantics. Evaluation. Member expression. Member expression. Expression. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C E S S capital W I T H capital E X P R base value expression strict 60 ECMA International 2024 member expression identifier name let base reference be evaluation of member expression let base value be get value base reference if the source text matched by this member expression is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base val UE identifier name strict member expression private identifier let base reference be evaluation of member expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string call expression let base reference be evaluation of call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name let base reference be evaluation of call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier let base reference be evaluation of call expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R takes arguments base value an ECMAScript language value expression an expression parse node and strict a boolean and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be Evaluation of expression. Let property name value be. Get value, property name reference. Let property key be. To property key, property name value. Return the reference record. Base value, property key, strict. This value, empty. 3, 3, 4, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict. The abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes argument space value, an ECMAScript language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name, return the reference record. Base value, property name string, strict, empty. ECMA International 2024 261 133 5 Then new operator 3 3 5 1 runtime semantics evaluation new expression new expression return evaluate new expression empty member expression new member expression arguments 1 return evaluate new member expression arguments 3 3 5 1 1 evaluate new construct expa arguments. The abstract operation evaluate new takes arguments cons, struct expa, a new expression parse node or remember expression parse node, and arguments, empty or an arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of construct expa. Let constructor be. Get value. Ref. If arguments is empty, then a let arglist be a new empty list for. Else a let arglist be. Argument list evaluation of arguments. If this constructor is false, throw a type error exception. Return. Construct. Constructor. Arglist. 3 3 6 function calls. 3 3 6 1 runtime semantics. Evaluation. Call expression. Capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Let expa be the call member expression that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Let member expa be the member expression of expa. Let arguments be the arguments of expa. Let ref be. Evaluation of member expa. Let func be. Get value. Ref. If ref is a reference record, is property reference, ref is false, and ref is eval, then if same value, func, %eval %, is true, then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, Let strict caller be true, otherwise let strict caller be false. V return. Perform eval. Eval arg. Strict caller. True. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression. Call expression arguments. Let ref be. Evaluation of call expression. Let func be. Get value. Ref. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Func. Ref. Arguments. Tail call. 62. ECMA International 2024. 13362 evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate call takes arguments func. An ECMAScript language value. Ref. An ECMAScript language value or a reference record. Arguments. A parse node. And tail position. A boolean. And returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference, ref, is true, then I let this value be get this value, ref be else I let ref env be ref. 2. Assert. Ref env is an environment record. 3. Let this value be ref env with base object, else let this value be undefined. Let arglist be. Argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Reto rn. Call. Func. This value. Arglist. 3. 7th super keyword. 3. 7. 1 runtime semantics. Evaluation super property. Super. Expression. Let env be get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key. Property name value. If the source text match by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super property. Super. Identifier name. Let env be get this environment. Let actual this be env get this binding. Let property key be string value of identifier name. If the source text match by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super call. Super arguments. Let new target be get new target. Assert. New target is an object. Let func be get super constructor. Let arglist be. Argument list evaluation of arguments. If this constructor, func, is false, throw a type error exception. Let result be. Construct. Func. Arglist. New target. Let the ser be get this environment. Perform the ser bind this value. Result. Let f be the ser 0. Assert. F is an ECMAScript function object. 1. Perform. Initialize instance elements. Result. F. 2. Return result. ECMA International 2024 263 133 To get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMAScript language value. It performs the following steps when called. Let envrec be get this environment. Assert. envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMAScript function object. Let superconstructor be active function. Return superconstructor. 3. 7. 3 make super property reference. Actual this. Property key. Strict. The abstract operation makes super property reference takes arguments actual this. An ECMAScript language value. Property key. A property key. And strict. A boolean. And returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env be get this environment. Assert. env has super binding. is true. Let base value be env get superbase. Return the reference record. Base value, property key, strict this value, actual this. 3. 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3, 3, 8, 1 runtime semantics. Argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language var, Louise, or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return list. See append next to list. Argument list. Argument list. Assignment expression. 1. 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return preceding args. See append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let cite obj be get template object. Template literal. Return cite obj. Template literal. Substitution template. Let template literal be this template literal. Let cite obj be get template object. Template literal. Let remain in be. Argument list evaluation of substitution template. Return the list concatenation of cite obj and remaining. Substitution template. Template head expression template spans. Let first subref be. Evaluation of expression. Let first sub be. Get value. First subref. Let rest sub be. Substitution evaluation of template spans. Assert. Rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 3. 9 optional chains. 3. 9. 1 runtime semantics. Evaluation. Optional expression. Member expression optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls, the first of which begins with the token ECMA International 2024 265. Optional expression. Optional expression optional chain. Let base reference be. Evaluation of optional expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. 3. 9. 2 runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R, base value, expression, strict optional chain. Identifier name. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, base value, identifier name, strict optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R, new value, expression, strict optional chain. Optional chain. Identifier name. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, new value, identifier name, strict, 66, ECMA International 2024, optional chain, optional chain. Private identifier. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let field name string be the string value of private identifier. Return make private reference. New value. Field name string. The 3rd of March 2010 import calls. 3.3.1.0. 1 runtime semantics. Evaluation. Import call. Import. Assignment expression. Let referrer be get active script or module. If referrer is null, set referrer to the current realm record. Let arggraph be. Evaluation of assignment expression. Let specifier be. Get value. rgraph. Let promise capability be new promise capability %promise %. Let specifier string be completion to string specifier. If abrupt reject promise, specifier string promise capability perform host load imported module referrer, specifier string empty promise capability return promise capability 3 3 1 0 1 1 continue dynamic import promise capability module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call promise capability undefined module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined reason be return unused. Let onRejected be create built-in function rejected closure 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and onRejected and performs the following steps when called. A let link be completion module link be if link is an abrupt completion, then I perform call promise capability undefined link 2. Return unused. C let evaluate promise be module evaluate. D let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace module 2. Perform call promise capability undefined namespace 3. Return unused. E let unfulfilled be create built-in function fulfilled closure 0. F perform promise then evaluate promise unfulfilled onRejected. G return unused. Link and evaluate be create built-in function link and evaluate closure 0. Let perform promise then load promise link and evaluate onRejected. Return unused. ECMA International 2024 267. The 13th of March 2011 tag templates 3 3 1 1 1 runtime semantics evaluation member expression template literal. Let tag ref be evaluation of member expression. Let tag fun be get value tag ref. Let this call be this member expression. Let tail call be as in tail position this call. Return evaluate call tag func tag ref template literal tail call expression template literal. Let tag ref be evaluation of call expression. Let tag fun be get value tag ref. Let this call be this call expression. Let tail call be as in tail position call. Return evaluate call tag func tag ref template literal tail call. The 3rd of March 2012 meta properties 3 3 1 2 1 runtime semantics evaluation new target 1. Or throw import form host finalize import meter module set module to import meter f return import meter else assert import meter is an object b return import meter 3 3 1 2 1 host get import meter properties module record. The host defined abstract operation host get import meter properties takes argument module record and returns a list of records.
when I click the button, it doesn't switch the screen. It's a waste of time opening a pop and doing the switch to BRB screen. This streaming software sucks.
Date object 13
So I'm gonna
in the
try to talk louder than the fan
roll 68
because I need the fan on. I feel like the airflow is so much nicer. Is it a little loud? Just a little,
the host defined
but it could be louder. I don't know. It's too much work to click the button, turn the fan off, walk back over, sit down. So I'm just gonna leave the fan on.
properties and leave host finalize import meter with it.
Man, that fan is loud though. Anyways, I don't know how loud this is. I got turned down maybe. Without testing.
Expression syntax. Update yield. Await. Left hand side expression yield await. Left hand side expression yield.
I can't find a software that'll remove the fan noise. I have like a gaming headset. It sucks. But it's actually able to remove the fan noise. I can't find software to do it. I'm not going to wear a gaming headset over my head. It's so annoying
It is
to wear a freaking headset.
it type of left hand side expression is not simple. Update expression plus
So,
target type of unary expression is not simple. 3, 4, 2 post
basically,
time semantics. Evaluation. Update expression.
I'm going to move this stuff to another notes file.
B. Evaluation of left hand side expression. Let old value be to numeric. Get value. LHS. If old value is a number, then a let new value be number. Add old value 1. Else assert old value is a bigint. B. Let new value be bigint. Add old value 1z. Perform. Put value LHS new value. Return old value. ECMA International 2024 269 134 3 postfix decrement operator 134 1 runtime semantics. Evaluation. Update expression. Left hand side expression.
Okay, so
Let old value be.
the get system time is precise as val time.
New value be number. Subtract.
That has
Let new value be begint. Subtract. Old value.
100 nanosecond resolution.
New value. Return.
Chatbot said,
Increment operator 13.
okay, whatever. It's not that precise. Not precise enough.
Expression. Plus unary expression.
The RDTSC gets a timestamp. The CPU, whatever.
Expa. If old value is a number, then a let new value be number. Add old value.
Does that sound? No, that's not worse.
Be let new value be begint.
Testing. Testing.
Put value.
Test. Testing. Test. I don't know, they all sound bad.
X. Evaluation. Update.
Testing. It's a fan. I'm not gonna turn it off. It's too much work to turn off.
Get value. Expa. If old value is a number, then a let new value be number. Subtract. Old value.
I'll just let the fan speak for me. Whatever it says.
International 2000.
I can't focus today. Anyways, to get system precise file time, it has 100 microsecond resolution.
Await plus unary expression yield await. Unary expression yield await. Unary expression yield await. Unary expression yield await. Plus await. Await expression yield 3.
Which means, I'm gonna double check the chatbot.
6. Early errors. Unary expressio n. Delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression, identifier reference, member expression, private identifier, call expression, private identifier, optional chain, private identifier, or optional chain, private identifier. It is a syntax error if the derived unary expression is primary expression, capital C O V E R, capital P A R E N T H
Okay, so
I Z E D, capital E X P R E S S I O N, capital A N, and capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1. To runtime semantics. Evaluation. Unary expression. Delete unary expression. Let ref be. Evaluation of unary expression. If ref is not a reference record, return true. If is unresolvable reference, ref is true, then assert ref is false. P return true. If is property reference, ref is true, then assert is private reference, ref is false. B if is super reference, ref is true. Throw a reference error exception. C let base obj be. To object, ref. D let delete status be base obj, ref. E if delete status is false and ref is true, throw a type error exception. F return delete status. Else a let base be ref. B assert base is an environment record. C return base delete binding, ref. The last rule means that expressions such as delete foo produce early errors because, note, of recursive application of the first rule. ECMA International 2024 271. Note 1. When a delete operator occurs within strict mode code, a syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note 2. The object that may be created in step 4c is not accessible outside of the above abstract operation in the ordinary object internal method. An implementation might choose to avoid the actual creation of that object. 3, 5, 2. Avoid operator. 3, 5, 2, 1. Runtime semantics. Unary expression. Void. Evaluation of.
my phone won't charge. Keeps saying charging on hold. Charging will resume when the iPhone returns to normal temperature. And it's not even that hot.
Unary expression. If val is a reference record, then if is unresolvable reference, val is true. Return.
So there's a billion nanoseconds.
Return
Where chatbot says, I think it's right. A billion nanoseconds in a second.
If val is a boolean, return boolean. If val is a number.
And get system time, precise as file time.
1. Assert Val is an object.
is 100 nanosecond precision.
6.
Now I'm like streaming this, so I want to make sure I don't mess anything up. I want to try to like be as accurate as possible, and if I make a mistake, then I make a mistake. But at least I tried to be accurate.
Because it may have observable side effects.
Because I could totally, anybody, I could like mess something up, forget a 0 in a billion, and then not notice it. So I don't know, I'm just trying to like make sure I don't miss anything.
Evaluation of
It would suck to like miss a 0 in a billion when computing stuff, and not realize it until later, and then find out all the numbers were fucked up. That's why I'm trying to like not mess this up. So I just want like accurate speed tests, even if it's not as accurate as I want. Just stable or something, I don't know. My best attempt. Because Windows sucks. I just want the time. I don't want this get system time, precise, this file time shit. Just give me the freaking time. I can't get that. So I gotta try to like make up a time from a known time interval, such as get system time, and then convert a unitless CPU cycle into something that represents a unit of time by translating it with division. It's ridiculous. Why can't, it's 20, 25. Why can't Windows just pass back the time? It's really simple. Just give us the time. But no, you just don't get the time of day to get the simple time. Time and time and time again. Alright, this time I gotta stop with all the time things. I can't go over the same time joke again. It's timeless though. Alright, that's the last time I'm making a time joke.
Exponentiation operator syntax. Exponentiation expression.
This is not funny. It wasn't funny anytime.
Expression yield.
I cannot focus.
National 2020.
So if I was trying to focus, I'm gonna like write out 1 million before I forget to.
An expression. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Update expression. Exponentiation expression. 3.7 multiplicative operators syntax. Multiplicative expression. Yield. Await. Exponentiation expression yield await. Multiplicative expression yield await. Multiplicative operator. Exponentiation expression yield await. Multiplicative operator. 1 of %. 3, 7. 1 runtime semantics. Evaluation. Multiplicative expression. Multiplicative expression. Multiplicative operator. Exponentiation expression. Let op text be the source text match by multiplicative operator. Return.
Okay, so 1 million nanoseconds in a second. There's 100 nanoseconds represented by the value passed back by get system time, precise as this file system time. RETSC is the CPU cycles. It's not related to time, just what the CPU is doing as CPU work. So these are both inaccurate, and if I merge them into a single value, I'm pretty sure the result is no more accurate. If anything, it's twice as inaccurate as leaving them separate. So I'm going to print a table where I'm going to print the merged values, which is probably twice as inaccurate way to present data, because if it's too inaccurate values, it's not going to be any more accurate by putting together. It's like two lefts don't make a right, or is it two rights don't make a left? Whatever it is. Two ups don't make a down. Well, I don't know, whatever. So, I'm going to use a list macro I have above yesterday. I'm just going to recycle it and repurpose it to like pre-compute. I'm going to have to print to a file this little window in the windows that I make when I run the program. This thing sucks for freaking, I hate this thing. It's blurry as fuck. I can't fucking read it. I'm not going to go through the effort of making the font bigger. I'm not going to look up how to make different windows, because Windows can suck it. It's what they do all day. That's why the updates break more than they fix. So you're too busy sucking it. Sucking each other's Microsofties. Or that'd be a micro hardy. I don't know. So, there's 100 nanoseconds, and 1 second is 100 nanoseconds, represented by get time precise as file time. So I have to do the value returned from get time precise as file time. I have to multiply that by 100 to get the nanoseconds. So, the thing about scaling a number, I asked Chatbot, and it kind of cleared it up, but it didn't, because Chatbot said you divide one by the other. So the known units, you divide it by the unknown. So that means they do like get system time, persistent file time, divided by RDTSC. So that's like, or I have to do it the other way. The get system time is going to be a smaller number. Can I just flip it around? Because it's going to be negated. I'll just ask Chatbot again. I don't know, this sucks ass. Why can't I just get the time in Windows? Just give me the fucking time. But no. I gotta like be creative. Okay, so I'm like ask Chatbot again, but basically I forgot that this number is gonna be smaller than the cycle count. A lot smaller. So I can't divide it. I gotta flip it or something. So Chatbot said you divide the two numbers and you multiply by a scale. The thing about multiplying by a scale is it doesn't make it any more accurate. If anything, it's just making it a bigger number. If something takes 10 seconds and you divide it by a unitless number, or 100 seconds, you divide it by 10. Is that 10? I don't know, I'm tired. Let's say it's 10. If you want to scale that up to like, since you divide it by 10, if you want to scale it back to 100, okay, so like, if you want to, well that, scaling is pointless. You're just adding back to the number you took from. I don't know. Basically though, since 100 nanoseconds is less than, it's a total representation of 100 nanoseconds. So since get system file time, it can only represent this of a nanosecond. Is that 7? Okay. I was thinking I'll take the result of this, multiply it by 100 to get it to like a fake nanosecond value. And then I want to compare this result to what Windows passes back for the high resolution timer, because I think this might be what Windows is doing for the high resolution timer. And if this is anywhere close to what Windows gets for the high resolution timer, I'm going to be very, very disappointed, because then it means I wasted my fucking time doing what's already been done in a suboptimal way, trying to make something more accurate when it's not in the first place. And if that's true, I'm gonna be really kind of angry. I mean, like, it's 2025, and this current state of technology is absolute shit. I mean, the CPU's faster, but what the fuck does the customer get out of it? We get fucking 100 nanosecond precision. We get no access to hardware. Everything's fucking virtualized. I hate computers. I hate Windows. I don't know. I'm gonna keep going though. I'm gonna make some money. These people are fucking idiots. So I'm gonna make money making a real thing. Something that's worth buying off of this shit show. Competing in a shit show is shit. I'm just gonna accept it. I don't know. I want to make another joke. I gotta stop and try to focus. So I'll multiply this by 100, I think. Let's chat out really quick, if that's what I do, to scale it to nanoseconds. And then I don't know, since this would take the stable time, if you want to call it that, divided by the unitless time to give it a unit, scaling it up to 100 doesn't actually make it any more accurate. It just adds some zeros to it, or some column placeholders to the number. But then it's kind of like a fake nanosecond, if that makes sense. Which it kind of does, but I don't know. So whatever this fake, probably twice as inaccurate number, because two inaccurate numbers aren't going to be any more accurate. It's kind of like thinking 2 heads or 10 heads will be smarter than one person, but no. If someone's smarter than 10 people, I mean, some people are just so dumb. Just real dumb as a doorknob. And like, the more heads you get, just honey is smarter. But I'm gonna do this whatever, so I'll get this what do we call it? I need to give it a unit. Like fake seconds, or sigma seconds per second? No, I don't know. I come up with like, I don't know, it doesn't matter. Oh, synthetic nanos per second, I'll call it that. Or artificial nanoseconds? I'll call it that. Artificial nanoseconds. However you spell artificial. Or artificial nanos. I don't know, it doesn't matter. It really doesn't matter. Why am I wasting my time? So this would be my artificial nanos per second number. I think you'd multiply by 100. I'll double check. is it called?
Or 207.
I could call it Splendas per second, because Splenda is like a fake sugar. They are like that. Splendas per second. It's fancy. So, a mass chatbot, what I would multiply by to theoretically scale it to what would be considered as a nanosecond per second, because it's 100 nanoseconds resolution, granularity, and it's not even close, and it's a piece of shit, but it's close enough. But since the CPU cycle is going to be larger than it, if I scale it up a little bit to bump the number, at least it's a bigger number. It's a fake number. It's fake in the first place. Two fakes doesn't make a real. But I don't know. So whatever this Splendas per second, I don't know, I like it. So I'm gonna print Splendas per second. It's called Splendas. Or SS for Splendas second. No, that works. And then cycles. And then like one cycle a second. I don't know, that's good enough. So list macro that pre-computes the byte array for the string. Prints a table here, so I'll make 3 tables and have to print all 3 in a line next to each other. And I'm gonna have to get this table to print to a file. I guess we'll do that after I get it running. So mass chatbot, how to convert the result of get this process time divided by RDSCIC times 100, or not times 100. What I have to times it by to get a hypothetical nanoseconds per second. So I'll do that first, and I'll have that settled. And then I'm going to print this Splendas per second to this window. I'm going to get it all set up in one column, and then 100 nanoseconds, the next column, and then 1 cycles per second, the next column. So that way I have like the fake time, and then like the real time to complete the benchmark, and like the cycle time. So that way I can like see how inaccurate or accurate the Splendas per second is when compared to the inaccurate nanoseconds and also the inaccurate cycles per second. I like how they don't account for memory loads and stores with the cycles per second, because they don't want to like let you know how fast the memory is. I won't get into it. I need to stay on track. I have to get out this shit. So that's gonna give me all that. I'm gonna chat out really quick just to get this because I'm gonna forget. I'm gonna describe I'm gonna set up whatever to get the data samples, whatever, the benchmark samples.
Wait. Bitwise and expression in yield await. Bitwise or 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 expression in yield await. 3, 1, 2, 1 runtime semantics. Evaluation. Bitwise and expression. Bitwise and expression and equality expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, bitwise and expression, and equality expression. ECMA International 2024 279. Bitwise or expression. Bitwise or expression. Bitwise and expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, bitwise or expression. Bitwise and expression. Bitwise or expression. Bitwise or expression. Bitwise or expression. Return. Capital E V A L
Battery died.
E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, bitwise or expression. Bitwise or expression. 3.13 Binary logical operators syntax. Logical and expression in yield await. Bitwise or expression in yield await. Logical and expression in yield await. And bitwise or expression in yield await. Logical or expression in yield await. Logical and expression in yield await. Logical or expression in yield question mark await. Logical and expression in yield await. Coalesce expression in yield await. Coalesce expression head in yield await. Bitwise or expression in yield await. Coalesce expression head in yield await. Coalesce expression in yield await. Bitwise or expression in yield await. Short circuit expression in yield await. Logical or expression in yield await. Coalesce expression in yield await. 3. 1.3, 1 runtime semantics, evaluation, logical and expression and bitwise or expression. Letter FB. Evaluation of logical and expression. Letter val B. Get value. Ref. Let bool be to boolean. Val. If bool is false, return val. Letter FB. Evaluation of bitwise or expression. Return. Get value. Ref. Logical or expression. Logical or expression. Logical and expression. Letter FB. Evaluation of logical or expression. Letter val B. Get value. Ref. Let bool be to boolean. Val. If bool is true, return val. Letter FB. Evaluation of logical and expression. Return. Get value. Ref. 280. ECMA International 2024. The value produced by a and or operator is not necessarily of type boolean. The value produced, note, will always be the value of one of the two operand expressions. Coalesce expression head. Bitwise or expression. Letter FB. Evaluation of coalesce expression head. Letter val B. Get value. Ref. If a val is either undefined or null, then a letter FB. Evaluation of bitwise or expression be return. Get value. Ref. Else a return val. 3.14 Conditional operator. Syntax. Conditional expression in yield await. Short circuit expression in yield await. short circuit expression in yield await, assignment expression, plus in yield await, assignment expression in yield await. 3.1.4. 1 runtime semantics, evaluation, conditional expression, short circuit expression, assignment expression, letter FB. Evaluation of short circuit expression, let val be to boolean. Get value, ref. If val is true, then let true ref be. Evaluation of the first assignment expression be return. Get value, true ref, else let false ref be. Evaluation of the second assignment expression be return. Get value, false ref. Note the grammar for a conditional expression in ECMAScript is slightly different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMAScript is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International 2024 281 13.15 Assignment operators syntax. Assignment expression in yield await. Conditional expression in yield await plus yield. Yield expression in or 8 arrow function in yield await. Async arrow function in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await. Assignment operator assignment expression in yield await. Left-hand side expression yield await. And equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Assignment operator, one of, equals percent equals plus equals and equals. 3.1.5. 1 static semantics, early errors. Assignment expression, left-hand side expression equals assignment expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. Assignment expression, left-hand side expression assignment operator assignment expression left-hand side expression and equals assignment expression left-hand side expression equals assignment expression left-hand side expression equals assignment expression. It is a syntax error if assignment target type of left-hand side expression is not simple. 3.1.5. 2 runtime semantics, evaluation, assignment expression, left-hand side expression equals assignment expression. 82. If left-hand side expression is neither an object literal nor an array literal, then a letter FB. Evaluation of left-hand side expression, if is anonymous function definition, assignment expression, and is identifier ref of left-hand side expression are both true, then I let val be. Named evaluation of assignment expression with argument ref. See else I let ref be. Evaluation of assignment expression 2. Let val be.
There we go. So I have to multiply it,
Ref.
the result or whatever,
Let us
times 10,000. And that will get me from 100 nanosecond units to actual nanoseconds per second. Right or no? What's this times 100?
RING capital ASSIGNMENT capital EVALUAT of assignment pattern with argument reval. Return reval. Assignment expression, left-hand side expression assignment operator assignment expression letter FB. Evaluation of left-hand side expression letter val B.
Okay, so this times 100. So if it was 1 nanosecond,
Assignment
I have to multiply it by 100, because that's how many nanoseconds 1 nanosecond is represented by gets this time per second time. So I guess 100. So to multiply it, hold on. 1 times so it's 10 million.
R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, text, reval, perform, part value, ref, R, return R.
Whatever. Oh wait, no, that's right. X times 100 gets me back to this.
Of left-hand side expression is
Okay, so to get nanoseconds, to get 100 nanosecond representation to actual nanoseconds, because it returns 1, but it really means 100. Returns 2, it means 200. So when I leave it, it's a smaller unit. Because if I scale it up, it could overflow. It would be too big for the register. It's not going to, because it's going to be smaller times, or whatever. If I multiply this by 100, that gives me nanoseconds per second. If I multiply it by 10,000, gives me a millisecond. I want millisecond precision? I don't know.
identify a ref of left.
I just like ran both.
Else, a letter of B. Evaluation of assignment expression. B let reval B. Get value. Ref. Perform. Put value. Ref. Reval. Return reval. 3. 1 5. 3. Capital A. P. P. L. Y. Capital S. T. R. I. N. G. Capital O. R. Capital N. U. M. E. R. I. C. Capital B. I. N. A. R. Y. Capital O. P. E. R. Val. Text. Reval. The abstract.
Okay, so I'm gonna scale this up, I guess, by 100 or 1,000 to get 2 milliseconds. And then that's, I don't know, whatever. It's probably not accurate, no more accurate, or no less accurate than both the numbers, inaccurate numbers themselves.
Language value, text, comma percent, plus, and, or, and reval, an ECMAScript language value, and returns either a normal completion containing either a string, a begint, or a number, or a throw completion. It performs the following steps when called. If text is plus, then a letter from B. To primitive, val, B letter from B. To primitive, reval, see if prim is a string or reprim is a string, then I let lstrb. To string, prim 2. Let rstrb. To string, reprim 3. Return the string concatenation of LSTR and RSTR, dset val till prim, eset raval to reprim. Note: at this point, it must be a numeric operation. Let num be. To numeric, val. Let num be. To numeric, raval. If type, num, is not type, renum. Throw a type error exception. If num is a big int, then, note when this expression occurs within strict mode code. It is a runtime error if ref in step 1d, 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7, 6 is a reference to a data property with the attribute value false, to an accessor property with the attribute value abcd. Let if op text is return big int exponentiate num renum. If op text is comma return big int divide num renum. If op text is percent return big int remainder num renum. If op text is return big int unsigned right shift num renum. Operation be the abstract operation associated with op text and type num. In the following table, 84 ECMA International 2024 op text type num. Operation number exponentiate number multiply big int multiply number divide number remainder number add percent plus number big int number op text type num plus.
So I'm asking chatbot. Get time precise. Dang it. Just switch it. Get time precise all time. Value smaller. Low division. The opposite way achieve the same effect. Of giving uniless number some relation to time. And would multiply by 100 still scale. That nanosec per sec. Not 100 nanos per sec. This is boring. After this, I'm gonna get the code done. Speed test some stuff. Benchmark whatever.
Handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2 Step 1c differs from Step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, left operand, op text, right operand. The
How the fuck do I get the fucking time? Fuck. This is so stupid.
T, E.
Chatbot pisses me off. This piece of shit.
R, capital N, U, M, E, R, I, C.
Where the fuck did it pull the number?
N, A, R, Y, capital
Cycles per second. Where is it getting this number? Where?
points, and right operand, a parse node, and returns either a normal completion containing either a string, a big int, or a number, or an abrupt completion. It performs the following steps when called. Let ref b. Evaluation of left operand. Let val b. Get value. Ref. Let ref b. Evaluation of right operand. Let val b. Get value. Ref. Return. Capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, op text, raval, 3, 1, 5, 5. Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern, yield, await, object assignment pattern yield await, array assignment pattern yield await.
Okay, picked 10,000 because that's how many nanoseconds are in a second when represented as 100 per 1 nanosecond returned back. But why would you divide by the bigger number? I don't know how putting two fake numbers together makes it any more accurate. This is a stupid, why am I doing this?
Assignment target yield await. Assignment property list, yield, await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list, yield, await. Assignment elision element yield await. Assignment element list yield await. Assignment elision element yield await. Assignment elision element, yield, await. Elision naught assignment element yield await. Assignment property, yield, await. Identifier reference yield await. Initializer, plus in yield await opt property name yield await. Assignment element yield await. Assignment element, yield, await. Destructuring assignment target yield await. Initializer, plus in yield await opt. Assignment rest element, yield, await. Dart. Destructuring assignment target yield await. Destructuring assignment target, yield, await. Left-hand side expression yield await. 3, 1, 5, 5, 1 static semantics, early errors. Assignment property, identifier reference initializer opt. It is a
I fucking hate everything.
Assignment dress property. Destructuring assignment target. It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target, left-hand side expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. 86. Copyright sign, ECMA International 2024. It is a syntax error if assignment target type of left-hand side expression is not simple 13, 15, 5, to runtime semantics. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T.
I think it was 6F or 63C0A. I don't know. The cycle count is like, it gets us some time.
N.
It returns a value that looks like this.
S, I, G, N, M.
The RDTSC returns a value after subtracted to get the difference. Looks like this.
A, T, takes argument value, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the.
So clearly, this value is much larger than this. This doesn't look, it's a 1 or 2 even. It's usually 1. I'll say 2. Chatbot. So when you divide this 2 by this, you get fucking 0. Because it's a computer. It doesn't do decimal. I'm not going to do floating point.
U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment property list with argument value. Return unused. Object assignment pattern. Assignment dress property. Perform. Require object. Usable. Value. Let excluded names be a new empty list. Return. Capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A of assignment dress property with arguments value and excluded names. Object assignment pattern. Assignment property list. Assignment dress property. Perform. Require object coercible. Value. Let excluded names be. Capital P R O P E R T Y capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment property list with argument value. Return. Capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A of assignment dress property with arguments value and excluded names. Array assignment pattern. Let iterator record B. Get iterator value sync return. Iterator close. Iterator record. Normal completion. Unused. Array assignment pattern. Elision. Let iterator record B. Get iterator value sync. Let result be completion. Iterator destructuring assignment evaluation of elision with argument. Iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Elision not assignment dressed element. Let iterator record B. Get iterator value sync. If elision is present, then a let status be completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. Let result be completion. Iterator destructuring assignment evaluation of assignment dressed element with argument iterator record. ECMA International 2024 287. 4. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Let iterator record B. Get iterator value sync. Let result be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Elision not assignment dressed element opt. Let iterator record B. Get iterator value sync. Let status be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then if iterator record is false, return. Iterator close. Iterator record. Status. B return status. If elision is present, then assert status to completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. If assignment dressed element is present, then assert status to completion. Iterator destructuring assignment evaluation of assignment dressed element with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Status. Return status. 3. 1 5 5.
Okay, how does this even work? If you multiply the time by a bigger number, Now it's technically bigger than the denominator, which is 6 zeros away. But if you change the time, then it's not the same time anymore. You're not dividing, just change the number. Don't you have to apply it to the other number? Man, chatbot makes things confusing.
It collects a list of all destructured property keys. It is defined piecewise over the following productions: assignment property list, assignment property list, assignment property. Let property names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property list with argument value. Let next names be capital P R O P E R T Y, capital.
Chatbot doesn't even work. Yeah, when I type slash text, fixed point, open curly brace, fixed point, underscore, point, result, curly brace equals, fraction, curly brace, slash text, parentheses, number, numerator, end of curly brace, slash times, 655536, curly brace, slash text denominator, whatever I can, doesn't matter. That gives the integer. You can't type this into a calculator. How is artificial intelligence going to take anybody's job? They can't even format a website. They can't even output a result. They can't do anything correct. Why am I asking this? How to make a unitless time hold some relativity to real time. I think I'm done with this for now. This is just fucking annoying.
Evaluation of property name. Perform. Capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V, of assignment element with arguments value and name. Return name 3155 for runtime semantics. Capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A. The syntax directed operation. Capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A, takes arguments value, an ECMAScript language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment dress property, destructuring assignment target, let be. Evaluation of destructuring assignment target. Let rest obj be ordinary object create, %object prototype %perform. Copy data properties, rest obj, value, excluded names, return. Put value, ref, rest obj, 3155 runtime semantics, capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. The syntax directed operation. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N takes argument iterator record, an iterator record, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment element list, assignment elision element, return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment elision element with argument iterator record, assignment element list, assignment element list, assignment elision element, perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment element list with argument iterator record, return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment elision element with argument iterator record, assignment elision element, assignment element, return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment element with argument iterator record, assignment elision element, elision assignment element, perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of elision with argument iterator record, return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment element with argument iterator record, elision. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true, see return if abrupt. Next. D if next is false, set iterator record to true, return unused. Elision. Elision. Perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N a collision with argument iterator record. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true. ECMA International 2024 289. See return if abrupt. Next. D if next is false, set iterator record to true 3. Return unused. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then elect if b. Evaluation of destructuring assignment target. Let value be undefined. If iterator record is false, then elect next b. Iterator step value. Iterator record. B if next is not done, then I set a value to next. If initializer is present and value is undefined, then if is anonymous function definition, initializer, is true and is identifier ref of destructuring assignment target is true, then I let VB. Named evaluation of initializer with argument ref b else I let default value be. Evaluation of initializer 2. Let VB. Get value. Default value else I let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Be return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument v return. Put value ref v assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then elect ref b. Evaluation of destructuring assignment target. Let a be. Array create 0. Let 0 repeat. While iterator record is false, elect next be. Iterator step value. Iterator record b if next is not done, then I perform. Create data property or throw a to string n next 2. Set n to n plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value ref a. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument a 3 1 5 5 6 runtime semantics capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V. The syntax directed operation capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V takes arguments value, an ECMAScript language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment element, Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then let be. Evaluation of destructuring assignment target. Let VB. Jet. Value. Property name. If initializer is present and v is undefined, then 290. ECMA International 2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition, initializer, and is identifier ref of destructuring assignment target are both true, then I let RHS value be. Named evaluation of initializer with argument ref be else I let default value be. Evaluation of initializer 2. Let RHS value be. Get value. Default value else I let RHS value be v. If destructuring assignment target is either an object literal or an array literal, then I let assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A L U A T, of assignment pattern with argument RHS value return. Put value ref RHS value 3.16 comma operator syntax expression in yield await assignment expression in yield await expression in yield await assignment expression in yield await 1316 1 runtime semantics evaluation expression assignment expression let ref be. Evaluation of expression perform. Get value ref let ref be. Evaluation of assignment expression return. Get value ref for ECMAScript language. Statements and declarations syntax. Statement yield await return. Block statement yield await return. Variable statement yield await. Empty statement expression statement yield await. If statement yield await return. Breakable statement yield await return. Continue statement yield await. Break statement yield await. Plus return. Return statement yield await. With statement yield await return. Labeled statement yield await return. Throw statement yield await. Try statement yield await return. Debugger statement. Note get value must be called even though its value is not used because it may have observable side effects. ECMA International 2024 291. Declaration. Yield. Await. Hoistable declaration yield await. Default. Class declaration yield await. Default. Lexical declaration. Plus in yield await. Hoistable declaration. Yield. Await. Default. Function declaration yield await. Question mark default. Generator declaration yield await default. Async function declaration yield await default. Async generator declaration yield await default. Breakable statement. Yield. Await. Return. Iteration statement yield await return. Switch statement yield await return. 4.1 Statement semantics. 4.1. 1 Runtime semantics. Evaluation. Hoistable declaration. Generator declaration. Async function declaration. Async generator declaration. Return empty. Hoistable declaration. Function declaration. Return. Evaluation of function declaration. Breakable statement. Iteration statement. Switch statement. Let new label set be a new empty list. Return. Labeled evaluation of this breakable statement with argument new.
So, I don't know. Numbers suck. It's all fake. I'm just gonna print the 2 times separate. Or I'll throw later. Because if you use fixed precision, yet basically I'll check outside or serious stop reading. So as chatbot is scaling the number being gives us some time, this scaling it to a bigger number, which chatbot said to scale it to a number that looks like this. Because that way this number is larger, and then you can divide, and then that would technically be a remainder that chatbot says is equivalent to what happens with floating point. So I'll just have chatbot read this whatever, or Siri read whatever this says. I don't want to argue with chatbot. This is pointless. This doesn't give me what I want. Then I would have to like find the highest bit and then use that as the scale amount. It's more than I want to do. I just want to like divide 2 numbers. But the system time, as precise as file time, is always smaller than the cycle count. So I'm gonna just do this part later. I'm gonna try to get done with the routine. Here's what chatbot says about scaling the number and floating point.
RDTSC value, compiler explorer, speed dial, 32-bit registers on. Does scaling yield the same result as with using floating point? Great question. Here's the short and clear answer. Does fixed point scaling yield the same result as floating point in an ideal, perfectly precise world? Yes. Scaling, fixed point, and floating point represent the same number mathematically. Fixed point scaling is an integer approximation with limited fractional bits. Floating point has a different format, sign, exponent, mantissa, and can represent a much wider dynamic range and more precise fractional values in many cases. Yes, internally, floating point numbers do involve a form of scaling, but it's fundamentally different from fixed point scaling. Dynamic scaling via exponent, base 2, static scaling by fixed multiplier, for example, 232. So in your scenario, floating point does internally scale the number by adjusting the exponent to keep the mantissa within a certain range. This is different from multiplying numerator by a fixed constant before division fixed point. Floating point is more flexible and handles fractional and large small values more naturally. Let me know if you want a breakdown of how IEEE 754 floating point formats store a specific number internally. What is the fixed point uses manual multiplication by a fixed scale factor, the fixed scale factor used for floating point. Great follow-up. To clarify, fixed point uses manual multiplication by a fixed scale factor, like 216, 232, or 109, in your code to represent fractions as integers. Floating point, on the other hand, does not. Instead, it stores numbers internally as. Here, the scale factor is dynamic. The exponent changes per number to shift the decimal, binary, point left or right. Scale factor is dynamic. Scale factor is dynamic. This exponent acts as an internal power of 2 scale factor that varies with each stored value. Fixed point manual fixed. For example, multiply by 232. Programmer chooses scale factor in code. No fixed scale factor in floating point. Each value has its own exponent controlling scaling. If you want, I can show the binary layout of a floating point number and how. So floating point literally picks the smallest number without being too large when scaling numbers, and then retains the scale, because it is not the same for all numbers. Exactly. You nailed it. Floating point picks the smallest scale, the exponent, that keeps the mantissa normalized and represents the number accurately. It retains this scale as part of the number's representation, so the same format can store both tiny and huge values efficiently. This is why floating point numbers can represent an extremely wide range of values with variable precision. So floating point literally picks the smallest number without being too large when scaling numbers, and then retains the scale, because it is not the same for all numbers. Exactly. You nailed it.
So I'm looking for like a better solution than this, because I kind of have an understanding, but I always try to like approach something I don't know, because that way I can't risk being wrong, and then people don't know what you know, and you learn what they know. I don't know. So I'll like figure this out later. I kind of have a clue what to do, but I don't like any of the solutions right now. I'm gonna like think about it and try to come up with like something more clever. So I'll just print them both differently right now, whatever. Okay, so like that's all the time stuff or whatever. So I'm gonna print, I guess for now, just keep them separate. I could just get floating point and then division and get a fake number, and that's gonna be good enough, I guess. I don't want to like write a whole routine to like compute the remainder and shit. Which is why people use floating point in the first place. Okay, so that's all that. So I'm gonna like, I need to get started now. No more distractions. So, what I need is some macrotized stuff. So everything's in like defined in one chunk, all the counters. So that's all my counters. I want one of them because I'm gonna have like the code, like the benchmark. And so like these are like the variables inside the benchmark. I need to make a macro to hold all of them in one place, whatever. Now when it runs, at the end, I want to have an array. Or like, not an array. For each of these variables, have an array of it. So these are like inside the benchmark. After it's done, the results are saved to the times whatever to these variables that are local. Outside the benchmark, I'll have an array. Array. Outside, right? I'll have like if this is for Microsoft Visual Studio Assembly, I have a counter. I'll tag it with an SVC's assembly, whatever. Just like the result count or whatever. So when I do the first benchmark, I'll set this to 0 or -1 to start with. I'll accumulate it. So now it's gonna be 0, whatever. And it's gonna store the result of the benchmark for Visual Studio in this array, for start array, end array, whatever. Except the length, I want to keep that like a variable. It's still going to be a simple time. It's like a literal. So I could say like, I want to run 20 tests, I want to run 30. I'll be able to like pick a number. So I could say like 34, and then to make an array to hold 34 of these, 34 of these, 34 of these. So the result will be here, and then I'll go to the array that's going to hold 34 of these. Otherwise, I have to write code and number each one of these, like 0, 1, 2, 3. It'll take way too long. This way, I have the local variables, whatever, and they'll get assigned to the stack after it completes each benchmark, whatever. So like it's like equals whatever the stack or the function, whatever the variable is, will be assigned to each of its own little array for that kind, and then I'll increment the stack each time. Let's put this after. So this is like the length or whatever. I like to like access it. You put the actual counter to pick the index or whatever. So like go to 0th, the first one, it's like 1. And at the end, I can simply loop through all these, make a simple loop, and print them to this window or whatever. and then everything's just aligned in place, and I can make simple loops. I don't have to deal with like passing over the name of the label, just align everything in memory. So like this is like, if this was a benchmark of code to run for Visual Studio Assembly. And this is like a benchmark for like Clang maybe. Where it says MSVC, I'm gonna have to like rename. So I need a macro I'm gonna make right now. So this would be like the counter for these. These would also be arrays, have to be tagged with a name. These variables would have to be tagged too. Instead of calling it my assembly, I'll just do that. Because I'm like the compiler, I guess. So then, these blocks, whatever, to run the routine in the middle, to benchmark. And then I don't want to run 20 of these in a row, 20 of these in a row. I want to run like one of these, two of these, three of these. I want to like jump around in memory. Because if I run a benchmark over and over and over again, I want to like randomize it to jump between, to try to like break up any like things that become a pattern. So like jump around between routines to test. So I probably need to make a list macro that has a list of the names I'm using, like MSVC, Clang, and John's code, or whatever. So I can pass around a list to macros to make sure like it has a length and it'll pre-compute the things in the list where it's placed, so I don't have to manually do anything. It'll just all run in a macro, if that makes sense. I also have to like adjust the data, change things, but I don't know. I'm gonna macrotize the shit out of it. So that's the plan. And I'll figure out the time thing, whatever. I'll just have to use floating point to be lazy. And then I'll be able to like benchmark Visual Studio, Clang, and my assembling. Figure out how slow the C compiler is at making assembly, and if it's worth writing assembly. I don't know. If it, if it wasn't worth writing assembly, I wouldn't be going through all this effort. So I'm pretty sure it'll be worth it. It better be worth it. This is a whole lot of effort just to find out. So I'm gonna make a copy of this, put in the notes, and then I'll get back and start programming whatever. And I'm just gonna like start programming and see where I get. If I start talking again, I'm gonna get distracted. But I think this will work, or whatever. I don't know. This is like the simplest way that I can think of doing this, which isn't very simple. But I don't want to like make a whole bunch of lazy ass counters and forget something, or have to add another thing, and I keep track of this. This way everything is just streamlined or whatever. This way I can like just click run, see the result. That's it. Not like click run and I want to like do 20 tests or 50 tests and have to go through, change a bunch of arrays. This way everything's like, it'll all be generated based on what the parameters are. So I'm gonna, I don't know, get back and start working this whatever. I think I should be able to like run some kind of test code and not too long. If I can focus and like just get done. This isn't that complicated. It's just a matter of like renaming things and adjusting the macros. Because I already thought through what I need or whatever, so I'll just throw it together. And if you ask chatbot something, whatever, and you give it like a clue of what you're talking about, and it just takes what you said and then tells you what you want to hear. So like, I don't know, I try to ask it without giving it a specific answer to see whatever it pulls up, because somehow it's able to know it's saving a cookie somewhere, because I know something about the history with some of the answers, because it's like, why didn't know to ask that, why didn't know that. So I don't know, that's why I try to ask it like, I don't know. And then if I ask it something and I have some kind of hint onto what I know, and I give it to it, it'll just play off it and just like get further and further away from like what I was trying to ask it or whatever. So I'm gonna like undo all the crap I just typed up in this file, and BRB, and I think I should be able to benchmark some stuff if I can throw it all together. I do have to look up how to make lists in an ASM, like a assembly time lists, so that's going to take some time, hopefully not too long, and I hope chatbot can give me an actual like example of how to make a list. If it doesn't, I have to read the documentation. I don't know, that might take a bit to figure out, so maybe I won't get done, maybe I will. Hopefully I get done. I don't want to do this tomorrow. If I do this tomorrow, it'll just be benchmarking. I'll probably spend a day benchmarking, just to really be sure, whatever. And I'll get back to like writing the JavaScript engine and going through this standard. don't know, with division, you expand the number to pick a number bigger than the other number. Because it, like, so numbers are in a column. You need a bigger column. I don't know. I won't bother explaining it. You can figure it out if you look into it. So, I don't know, I didn't run it yet today. Looks like everything works. I'll save another backup because I can. You never have too many backups until you run out of space. That's when you have too many backups because you ran out of space. So you need more room to save more backups that you can't have too many of. You also can't ever delete a backup because once you delete a backup, you can't go back to it. So I'm going to break my rule and delete some backups. And they will be gone. It'll be history that's been deleted because they're no longer backed up. Hasta la vista. Double check that I'm actually only deleting I need to delete. I gotta wait to complete. And, oh baby, and go to finish up the script.
Template literal. Call expression. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Supercall. Import call. Call expression arguments. Call expression template literal. New expression. New expression. Member expression. Member expression template literal. New member expression arguments. ECMA International 2024 131. New target. New target. Import meter. Import meta. Left hand side expression. Optional expression. Update expression. Left hand side expression plus plus. Left hand side expression. Plus plus unary expression, unary expression, unary expression, delete unary expression, void unary expression, type of unary expression plus unary expression, unary expression, unary expression, unary expression, await expression, exponentiation expression, update expression, exponentiation expression, multiplicative expression, multiplicative expression, multiplicative operator, exponentiation expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instance of shift expression, relational expression in shift expression, private identifier in shift expression, equality expression equals relational 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 expression, bitwise and expression and equality expression, bitwise or expression, bitwise and expression, bitwise or expression, logical and expression, and bitwise or expression. 32. ECMA International 2024. Logical or expression, logical and expression, coalesce expression head. Bitwise or expression, conditional expression, short circuit expression, assignment expression, yield expression, arrow function, async arrow function. Left-hand side expression equals assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression, and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, assignment expression, return invalid, 6.5 static semantics. Prop name. The syntax-directed operation prop name takes no arguments and returns a string or empty. It is defined piecewise over the following productions. Property definition. Identifier reference. Return string value of identifier reference. Property definition. Assignment expression. Return empty. Property definition. Property name. Assignment expression. Return prop name of property name. Litera. L property name. Identifier name, return string value of identifier name. Literal property name, string literal, return the SV of string literal. Literal property name, numeric literal, let NBR be the numeric value of numeric literal, return. To string, NBR, computed property name, assignment expression, 1. Return empty, ECMA International 2024 133. Method definition, class element name, unique formal parameters. Function body, get class element name. Function body, set class element name. Property set parameter list. Function body. Return prop name of class element name. Generator method. Class element name. Unique formal parameters. Generator body. Return prop name of class element name. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return prop name of class element name. Class element. Class static block 1. Return empty. Class element 1. Return empty. Async method. Async class element name. Unique formal parameters. Async function body 1. Return prop name of class element name. Field definition. Class element name initializer opt1. Return prop name of class element name. Class element name. Private identifier 1. Return empty. Executable code and execution contexts. 9.1 Environment records. Environment record is a specification type used to define the association of identifiers to specific variables and functions, based upon the lexical nesting structure of ECMAScript code. Usually an environment record is associated with some specific syntactic structure of ECMAScript code, such as a function declaration, a block statement, or a catch clause of a try statement. Each time such code is evaluated, a new environment record is created to record the identifier bindings that are created by that code. Every environment record has an field, which is either null or a reference to an outer environment record. This is used to model the logical nesting of environment record values. The outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment record. An environment record may serve as the outer environment for multiple inner environment records. For example, if a function declaration contains two nested function declarations, then the environment records of each of the nested functions will have as their outer environment record the environment record of the current evaluation of the surrounding function. Environment records are purely specification mechanisms and need not correspond to any specific artifact of an ECMAScript implementation. It is impossible for an ECMAScript program to directly access or manipulate such values. 34. Copyright sign. ECMA International 2024. 9. 1. 1. The environment record type hierarchy. Environment records can be thought of as existing in a simple, object-oriented hierarchy where environment RD is an abstract class with three concrete subclasses: declarative environment record, object environment record, and global environment record. Function environment records and module environment records are subclasses of declarative environment record. Environment record. Abstract. A declarative environment record is used to define the effect of ECMAScript language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier bindings with ECMAScript language values. A function environment record corresponds to the invocation of an ECMAScript function object, and contains bindings for the top-level declarations within that function. It may establish anew this binding. It also captures the state necessary to support supermethod invocations. A module environment record contains the bindings for the top-level declarations of a module. It also contains the bindings that are explicitly imported by the module. It is a global environment record. An object environment record is used to define the effect of ECMAScript elements such as with statement that associate identifier bindings with the properties of some object. A global environment record is used for script global declarations. It does not have an outer environment. It says null. It may be prepopulated with identifier bindings, and it includes an associated global object whose properties provide some of the global environment's identifier bindings. As ECMAScript code is executed, additional properties may be added to the global object and the initial properties may be modified. The environment record abstract class includes the abstract specification methods defined in Table 16. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Table 16. Abstract methods of environment records. Method purpose has binding n. Determine if an environment record has a binding for the string value n. Return true if it does and false if it does not. Create mutable binding n. D. Create a new but uninitialized mutable binding in an environment record. The string value n is the text of the bound name. If the Boolean argument D is true, the binding may be subsequently deleted. Create a mutable binding. N. S. Create a new but uninitialized immutable binding in an environment record. The string value N is the text of the bound name. If S is true, then attempts to set it after it has been initialized will always throw an exception, regardless of the strict mode setting of operations that reference that binding. Initialize binding. N. V. Set the value of an already existing but uninitialized binding in an environment record. The string value N is the text of the bound name. V is the value for the binding and is a value of any ECMAScript language type. Set mutable binding. N. V. S. Set the value of an already existing mutable binding in an environment record. The string v(n) is the text of the bound name. V is the value for the binding and may be a value of any ECMAScript language type. S is a Boolean flag. If S is true and the binding cannot be set, throw a type error exception. Copyright sign, ECMA International 2024, 35. Table 16. Abstract methods of environment records. Continued. Method. Purpose. Get binding value. N. S. Returns the value of an already existing binding from an environment record. The string value N is the text of the bound name. S is used to identify references originating in strict mode code or that otherwise require strict mode reference semantics. If S is true and the binding does not exist, throw a reference error exception. If the binding exists but is uninitialized, a reference error is thrown, regardless of the value of S. Delete binding. N. Delete a binding from an environment record. The string value N is the text of the bound name. If a binding for N exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Has this binding? Determine if an environment record establishes this binding. Return true if it doesn't. False if it does not. Has super binding? Determine if an environment record establishes a super method binding. Return true if it doesn't. False if it does not. With base object. If this environment record is associated with a with statement, return the with object. Otherwise, return undefined. 9. 1. 1. 1 declarative environment records. Each declarative environment record is associated with an ECMAScript program scope containing variable, constant, let, class, module, import, and/or function declarations. A declarative environment record binds the set of identifiers defined by the declarations contained within its scope. The behavior of the concrete specification methods for declarative environment records is defined by the following algorithms. 1. 1. 1. 1 has binding. N. The has binding concrete method of a declarative environment record. The envrec takes argument n, a string, and returns a normal completion containing a Boolean. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. If the envrec has a binding for n, return true, return false, 1, 1, 1. 2. Create mutable binding. N. D. The create mutable binding concrete method of a declarative environment record. The envrec takes arguments n, a string, and e, a Boolean, and returns a normal completion containing unused. It creates a new mutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if D is true. The new binding is marked as being subject to deletion. It performs the following steps when called. Assert. envrec does not already have a binding for n. Create a mutable binding in envrec for n and record that it is uninitialized. If D is true, record that the newly created binding may be deleted by a subsequent delete binding call. Return unused. 36. ECMA International 2024. 9. 1. 1. 1. 3. Create a mutable binding. N. S. The create a mutable binding concrete method of a declarative environment record. The envrec takes arguments n, a string, and s, a Boolean, and returns a normal completion containing unused. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if S is true. The new binding is marked as a strict binding. It performs the following steps when called. Assert. envrec does not already have a binding for n. Create an immutable binding in envrec for n and record that it is uninitialized. If S is true, record that the newly created binding is a strict binding. Return unused, 1, 1, 1. For initialize binding, n, v. The initialize binding concrete method of a declarative environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns a normal completion containing unused. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Assert. envrec must have an uninitialized binding for n. Set the bound value for n and envrec to v. Record that the binding for n and envrec has been initialized. Return unused, 1, 1, 1. 5. Set mutable binding, n, v, s. The set mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. A binding for n normally already exists, but in rare cases it may not. If the binding is an immutable binding, a type error is thrown if s is true. It performs the following steps when called. If envrec does not have a binding for n, then if s is true, throw a reference error exception. B. Perform envrec create mutable binding, n, true. C. Perform envrec initialize binding, n, v. D. Return unused. If the binding for n and envrec is a strict binding, set s to true. If the binding for n and envrec has not yet been initialized, then A. Throw a reference error exception. Else if the binding for n and envrec is a mutable binding, then A. Change its bound value to v. Else A. Assert. This is an attempt to change the value of an immutable binding. B. If s is true, throw a type error exception. Return unused. Note an example of ECMAScript code that results in a missing binding at step 1 is function f, eval, var x equals, delete x, 0, ECMA International 2024 137, 9, 1, 1, 1, 6. Get binding value, n, s. The get binding value concrete method of a declarative environment record envrec takes arguments n, a string, a, nds, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert. envrec has a binding for n. If the binding for n and envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n and envrec, 1, 1, 1. 7. Delete binding, n. The delete binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. envrec has a binding for n. If the binding for n and envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1, 1, 1. 8. Has this binding. The has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 9. Has super binding. The has super binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 1, 0. With base object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1, 1. 2. Object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide this binding. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide a super binding. 38. Copyright sign. ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. OBJ. ECT environment records created for with statements. 14.11 can provide the binding object as an implicit this value for use in function calls. The capability is controlled by
When I make like little jokes about people being dicks or whatever, I like don't hold anybody for anything or against them, whatever. Because really, I don't care. Like, being embarrassed enough for being stupid enough to be a little, I don't know. It's just, I really don't care. Like, the embarrassment enough of realizing how, like, I don't know. That's enough. I don't care. I'm just making little remarks. Like, seriously, I don't care. It's fine. I really don't care. I'd be so embarrassed. So embarrassed. Anyways, like, that's literally enough. That's why I don't care. I'm just making little remarks. The last time, whatever, I was talking about the AI register, and I asked Chat about something, and it kind of like said something, and I was trying to like get it to answer a question, and it wouldn't really answer me. Yeah, I got off track, whatever, but I found this website, whatever, randomly, and they talk about the AI register, whatever.
To see the problem, suppose you perform an 8-bit ALU operation on the R register, which is 15/8 of the X register. These bits must be shifted down to position 7 so they can take part in the ALU operation, and then must be shifted back to positions 15/8 when stored into R. On the other hand, if you perform an ALU operation on L, bit 7 of X, the bits are already in position and don't need to be shifted.
So, the other day, I think, I talked about using the AI register and how it's slower. And I made assembly like 2 routines, one where it uses AI register and one where it doesn't. It's right here, or where is it? Right here. So yesterday I think it was, I want to benchmark some stuff. That's why I'm writing stuff out. But this is like legitimate benchmarking. I've never took benchmarking this serious. I want to try to make sure I'm as accurate as possible because I want to benchmark things later when I get to JavaScript standard. When I'm going through the standard, I'm going to optimize the fuck out of JavaScript. JavaScript is me so fucking fast, so I need to make sure that I have speed testing, benchmarking, assembly, and C like as accurate as I can get it. So like this is like my first attempt to getting like good benchmarking, like really good benchmarking. Clearly this won't be the best. I'm gonna have to like modify my technique after I benchmark some things. I'll figure out as I'm going like how I can get better numbers and stuff. Like I should probably sample the CPU, get some times ahead of time, make a table and stuff like that to remove noise or try to remove noise and stuff. But for now I'm just gonna do this. This is good enough. I don't know, I'll like refine how I'm benchmarking later, but I just want to have a solid setup to start with. But the other day, whatever, I wrote this routine. I took too long writing it. I'm just trying to make sure that I got it down to like the minimal number of operations and tried to keep it the same. Like a whole bunch of things to account for. So I think this is like good enough. I want to like compare this to this. This one I don't use the A-high register. Instead I do RDX, I shift to right 8. No, that's for the data. That's a different thing. I mean, I shift left AX8. Because if I shift left AX8, that's the high and low part. That way I don't access. I wish this thing would just work when you double click and highlight. This way, using AX, I don't access a high directly. Because like in this documentation, or not documentation, this guy's pulling apart the CPU and investigating it. He says,
To see the problem, suppose you perform an 8-bit ALU operation on the R register, which is bits 15/8 of the X register. These bits must be shifted down to position 7 so they can take part in the ALU operation.
so the A-high register is above the AL. But internally, the CPU shifts them down to the bottom and shifts them back up after. And it says right here, whatever.
And then must be shifted back to positions 15/8 when stored into R.
I don't know, Siri doesn't really read it very good. It's AH, but it goes ah. It's not AH. So anyways, this process of shifting the 8 bits from A high down to A low and then shifting them back after the operation, it's actually very slow. So you try to avoid A high. But how much slower? I don't know. People just say it. And people found out when they pull apart CPUs that this is true. Intel documents it. They haven't documented that it actually shifts it down and shifts it back. Maybe they have. I haven't seen it. They just say that it breaks or creates dependencies or something on other things, installs things, because it's physically doing that internally. I don't think they explain the process in documentation until. So anyways, this one has AH, this one doesn't. Instead in this one, I shift left 8. So this way, I avoid the internal shifting down and shifting back. And I just do shift left 8, which is technically the same number because it has to shift it 8 and shift 8 when you do AH. So now, what I want to see though is, will this be faster than this? Because this is 1, 2, 3, 4, 5, 6, 7, 8 instructions. This one is 1, 2, 3, 4, 5, 6, 7 instructions. So what I want to see is, will this 8 instruction be faster because it doesn't use A high, or will this be faster because A high, even though slower, if you need to do the same thing, is it faster than using an extra instruction? And then when I write the assembly later, I will be able to account for that. And I have to make sure things are aligned in memory. So like the loops and data, I want to try to make sure that the loops and data and stuff are like aligned in memory. And there's a keyword in NASM, so I don't know. I'm going to try to get like legit testing so we can get like absolutely certain yes or no's on what's faster, what's not, test certain things. So when I go through the standard whatever, and I'm writing my JavaScript engine and optimizing things in assembly, I'll be able to get like more accurate on like more accurate ways to write code or whatever on the first try than having to take several tries at it or whatever, if that makes sense. I'm basically trying to like save time by figuring out whatever I can, making note of it, and I'll have like notes to look at, because figuring something out over and over and over and testing and all this stuff, it takes so much time. I have to find ways to start like saving time. And one of those ways to save time would be to write a new operating system. So I don't know. Someday a new operating system is going to come out and it'll save everybody's time. But it's not today. But one day. I'm just writing a JavaScript engine though. So what do I know? What kind of idiot would optimize JavaScript? But that's what I'm doing. So I'm not writing an operating system, I'm writing JavaScript engine. But someone will write an operating system one day. It's like inevitable, because Windows is so bad. And none of the companies are like really holding up. And Linux is kind of like, I don't know, Linux has just as many issues. They're both kind of, I'm just going to keep it to JavaScript and get to working or whatever. But I want to like see the speed difference in these, because I've never tested it and I just always try to avoid A high, and then when I test it I will be able to be like, okay, now I know. I don't know, it's good to know. So I'm gonna try to get to work and get this stuff set up for benchmarking stuff. It's already been like 8 hours. I spent way too long looking at the moon NASA stuff earlier. I did not. Time literally flies by. I only have like 3 hours or something to like get this stuff done. I didn't even start programming yet. At least I have everything all planned out. So I didn't lose time. I just didn't waste time writing code and undoing it. I just have like a really clear plan now. So I gotta shut up and get something done.
Erasing create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create, %object prototype %set obj to undefined. Perform. Define property or throw, obj, length, property descriptor, len, true, enumerable, false, true, let index be 0, repeat, while index, len, a let val be arguments list, index be perform, create data property or throw, obj, to string, index, val, c set index to index plus 1, perform, define property or throw, obj, at iterator, property descriptor, %array prototype values %, true, false, true, perform, define property or throw, obj, callee, property descriptor, %throw type error %, false, return obj, 0, 4, 4, 7 create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0, 4, 4, 1. Set obj is specified in 1 0, 4, 4, 2. Set obj is specified in 1 0, 4, 4, 5. Set obj to %object prototype %0. Let map be ordinary object create, null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat, while index, len, a let val be arguments list, index be perform. Create data property or throw, obj, to string, index, val, c set index to index plus 1, 6. Perform. Define property or throw, obj, length, property descriptor, len, true, false, true, 7. Let map names be a new empty list, 8. Set index to number of parameters 1, 9. Repeat, while index 0. 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names 2. If index, len, then let G be make arg getter, name, env. Let P be make arg setter, name, env. Perform map, exclamation point. To string, index, property descriptor, get, G, false, true, set index to index 1, 20. Perform. Define property or throw, obj, at iterator, property descriptor, %array prototype values %, true, false, true, 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true, 2. Return obj, 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name in env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note, getter is never directly accessible to ECMAScript code. Return getter, 0, 4, 4, 7, to make argsetter, name, env. The abstract operation make argsetter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let's set a closure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let's set a be create built-in function, set a closure. 1. Note, setter is never directly accessible to ECMAScript code. Return setter 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1, p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string, p. b. If numeric index is not undefined, then I let value be typed array get element. Oh, numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor value true, true, true. Return ordinary get own property. O. P. ECMA International 2024 195 10 4 5 2. P. The internal method of a typed array O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string, p. b. If numeric index is not undefined, return as valid integer index. O. Numeric index return. Ordinary has property O. P 0, 4, 5, 3, p. Desk. The internal method of a typed array O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string, p. b. If numeric index is not undefined, then if as valid integer index, O. Numeric index is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If as accessor descriptor, desk, is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element. Oh, numeric index, desk 7. Return true, return. Ordinary define own property, O, P, desk 0, 4, 5, 4. The, if P is a string, then a let numeric index be canonical numeric index string, P, B. If numeric index is not undefined, then I return typed array get element. Oh, numeric index 2. Return. Ordinary get, O, P, receiver 0, 4, 5, 5. The, if P is a string, then a let numeric index be canonical numeric index string, P, B. If numeric index is not undefined, then I have same value, O, receiver, is true, then perform. Typed array set element, O, numeric index, V, return true. 2. If as valid integer index, O, numeric index, is false, return true. Return. Ordinary set, O, P, V, receiver, 96. ECMA International 2024 10, 4, 5, 6. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. Capital I T performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P B. If numeric index is not undefined, then if is valid integer index, O numeric index is false, return true, else return false too. Return ordinary delete O P 0 4 5 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST. Let keys be a new empty list. If this typed array out of bounds tar record is false, then a let length be typed array length tar record be for each integer I such that 0 length in ascending order do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to keys 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O B J order. The abstract operation, capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S takes arguments obj, a typed array, and order, sexy st or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj. If is detached buffer is true, then a let byte length be detached. Field name value meaning object a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign ECMA International 2024 197. 3. Else a let byte length be array buffer byte length buffer order return the typed array with buffer witness record obj byte length 0, 4, 5, 1 0 typed array create prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internals lots list. Set A is specified in 1 0, 4, 5, 1. Set A is specified in 1 0, 4, 5, 2. Set A is specified in 1 0, 4, 5, 3. Set A is specified in 1 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1. Typed array byte length. tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1, 2. Typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds, tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert byte length is not detached. Return floor. Byte length. Byte offset. Element size 0, 4, 5, 1, 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert is detached buffer. O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else a let element size be typed array element size. O be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments O, a typed array, and index, a number, and returns a boolean. It performs the following steps when called. If is detached to for O is true, return false. If is integral number, index, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true, return false. Let length be typed array length, tar record. If R, index, 0 or R, index, length, return false. Return true. 0, 4, 5, 1, 5 typed array get element. O, index. The abstract operation typed array get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index, O, index, is false, return undefined. Let offset be O. Let element size be typed array element size. O. Let byte index in buffer be R. Index. Element size plus offset. Let element type be typed array element type. O. Return get value from buffer. O. Byte index in buffer. Element type. True. Unordered. 0, 4, 5, 1, 6 typed array set element. O. int x, value. The abstract operation typed array set element takes arguments so, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be. To big int, value. Otherwise, let num value be. To number, value. If as valid integer index, O, int x, is true, then a let offset be O, b let element size be typed array element size. O, c let byte index in buffer be, r, int x, element size plus offset. D let element type be typed array element type. O, e perform set value in buffer. O, byte index in buffer. Element type, num value, true unordered. Return unused. ECMA International 2024 199 104517 is array buffer view out of bounds. O, the abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R O sexy S T B return is view out of bounds. View record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST return is typed array out of bounds. Tar record 0 4 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module C16 2 3. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic C object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare FN 104661. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null 00. ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer 1046. 2. v. The internal method of a module namespace exotic object O takes argument v, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O v 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true 0 4 6 5. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when car led. If P is a symbol, return an ordinary get own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor value true, true, false 0 4 6 6. P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define own property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is accessor descriptor desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value desk. Current. Return true 0 4 6 7. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true, return false. ECMA International 2024 201 10 4 6 8. The. If P is a symbol, then a return ordinary get O. P. Receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M. Resolve export P. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace. Target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception 2. Return target env get binding value. Binding true 0 4 6 9. The return false 1 0 4 6 1 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return ordinary delete O. P. Let exports be O. If exports contains P, return false. Return true 0 4 6 1 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02. ECMA International 2024 10 4 6 1 2. Module namespace create module exports. The abstract operation module namespace create takes arguments module a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let n be make basic object. Internal slots list. Set m's essential internal methods to the definitions specified in 1.0.4. 6. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare fn. Set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0. 4. 7. Immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0. 4. 7. 1. V. The internal method of an immutable prototype exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return set immutable prototype O v10 4 7 to set immutable prototype O v. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value, v, current, is true. Return true. Return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34. Proxy handler methods. Internal method. Handler method. Get prototype of set prototype of is extensible. Prevent extensions. Get own property descriptor. Define own property. Has set delete property. Own property keys. Call. Apply. Construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, It is possible to define a proxy object whose handler methods viola test the invariants defined in 6, 1, 7, 3. Some of the internal method invariants defined in 6, 1, 7, 3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object. P is a property key value. V is any ECMAScript language value and desc is a property descriptor record. O for copyright sign. ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of if trap is undefined. Then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible. Target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined. Then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible. Target 0. If extensible target is true, return true 1. Let target proto be target 2. If same value, V, target proto, is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. Let target result be. Is extensible. Target. If boolean trap result is not target result, throw a type error exception 0. Return boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. If boolean trap result is true, then a let extensible target be. Is extensible. target. B if extensible target is true, throw a type error exception, return boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy, O. Let target be O, 06, ECMA International 2024. 3. Let handler be O, assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result objb. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then if target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be. Is extensible target. D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be. Is extensible target. 2. Let result desk be. To property descriptor. Trap result obj. 3. Perform complete property descriptor. Result desk. 4. Let valid be as compatible property descriptor. Extensible target. Result desk. Target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p. Desk. The internal method of a proxy exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desk. Let desk obj be from property descriptor. Desk. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desk obj. If boolean trap result is false, return false. 0. Let target desk be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible target. 2. If desk has a field and desk is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desk is undefined, then if extensible target is false, throw a type error exception. B. If setting config false is true, throw a type error exception. 5. Else if is compatible property descriptor, extensible target, desk, target desk, is false. Throw a type error exception. B if setting config false is true and target desk is true. Throw a type error exception. C if is data descriptor target desk is true. Target desk is false and target desk is true. Then, I if desk has a field and desk is false. Throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable. Unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined. Then a return target. P. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. If Boolean trap result is false. Then a let target desk be target. P. B if target desk is not undefined. Then, I if target desk is false. Throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false. Throw a type error exception. Return Boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The and called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined. Then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false. Then if is data descriptor. Target desk is true and target desk is false. Then I have same value. Trap result. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true and target desk 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined. Then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. V. Receiver. If Boolean trap result is false. Return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false. Then, ECMA International 2024 209. If is data descriptor. Target desk is true and target desk is false. Then I have same value. V. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true. Then I have target desk 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own access a property that has undefined as ITS 0510 P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array. String. Symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key be if desk is not undefined and desk is false. Then, I append key to target non-configurable keys C else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariants. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let array be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. Array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list. A list of ECMAScript language values. A new target. A constructor. And returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0. 5. 1 for validate non-revoke proxy. Proxy. The abstract operation validator. T non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0. 5. 1 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except for and, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P. 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers. Any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. within a comment. Such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics. UTF-16 encode code point. CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let CP1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let CP2 be the code unit whose numeric value is CP0 times 10,000. Modulo 0 times 400 plus 0 XDC00. Return the string concatenation of CP1 and CP2. ECMA International 2024 213. 1 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result. 1 3 static semantics. UTF-16 surrogate pair to code point. Led. Trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0 XD800. 0 times 400 plus trail 0 XDC00 plus 0 times 10,000. Return the code point CP. 1 4 static semantics. Code point at string. Position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index posit ion. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If the first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 full 6. If the first is a trailing surrogate or position plus 1 equals size, then return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes arguments string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string. Position be append CP to code points. Set position to position plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, see 10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024 215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1 function code is generally provided as the bodies of function definitions. 15.2, arrow function definitions. 15.3, method definitions. 15.4, generator function definitions. 15.5, async function definitions. 15.8, async generator function definitions. 15.6, and async arrow functions. 15.9. Function code is also derived from the arguments to the function constructor 20, 2, 1, 1. The generator function constructor 27, 3, 1, 1. And the async function constructor 27, 7, 1, 1. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues in the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2, 2 strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4, 3, 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign. ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1, 2, 3 non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined within ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2 ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element hashbang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: up equals b high g exec, c map, d, where the first non-white space, non-comment code point after a line terminator is u plus 002 f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as up equals b high g exec, c map, d syntax input element of white space li net terminator comment token div punctuator right brace punctuator input element regexp white space line terminator comment token right brace punctuator regular expression literal ECMA International 2024 217 capital I N P U T capital E L E M E N T capital R E G capital E X P capital O R capital T E M P L A T E capital T A white space line terminator comment token regular expression literal template substitution tail input element template tail white space line terminator comment token div punctuated template substitution tail input element hashbang or regexp white space line terminator comment token hashbang comment regular expression literal 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus f, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWMBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files. In ECMAScript source text, ZWMBSP, code points are treated as white space characters. See 12.2, the special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 218. ECMA International 2024. 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript white space code points are listed in Table 36. tar ble 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF, U plus FF, 0 width no break space, ZWNBSP, any code point in general category space separator, USP, no 1 U plus 0020, space, and U plus 00A0, no break space. Code points are part of USP syntax. Note 2, other than for the code points listed in Table 36. ECMAScript white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. ZEDS 2.3 white space tab VT FF ZWMBSP USP line terminators, like white space code points. Line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. MCR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024 219. The ECMAScript line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U plus 000. Line feed. LF. U plus 000D. Carriage return CR. U plus 2028. Line separator. LS. U plus 2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence, CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax, line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF. LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest. Because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible, a single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single-line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax. Comment. Multi-line comment. Single-line comment. 20. ECMA International 2024. Multi-line comment. Multi-line comment charsopt. Multi-line comment chars. Multi-line not asterisk char. Multi-line comment charsopt. Post asterisk comment charsopt. Post asterisk comment chars. Capital M U L T I. Capital L I N E. Capital N O T. Capital F O R W A R D. Capital S L A S H. Capital O R. Capital A S T E. Multi-line comment charsopt. Post asterisk comment charsopt. Multi-line not asterisk char. Source character but not. Capital M U L T I. Capital L I N E. Capital N O T. Capital F O R W A R D. Capital S L A S H. Capital O R. Capital A S T E. Source character but not one of all. Single line comment. Single line comment charsopt. Single line comment chars. Single line comment char. Single line comment charsopt. Single line comment char. Source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashbang comment. Single line comment charsopt. 2.6 tokens. Syntax. Common token. Identifier name. Private identifier punctuator. Numeric literal string literal template. Note the div punctuator. Regular expression literal. Right brace punctuator. And template substitution. Tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221. 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31. Identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax. Private identifier. Identifier name. Identifier name. Identifier start. Identifier name. Identifier part. Identifier start. Identifier start char. Unicode escape sequence. Identifier part. Identifier part char. Unicode escape sequence. Identifier start char. Unicode ID start. Underscore. Identifier part char. Unicode ID cont. Inu. ZWNJ. ZWJ. Assign letter. One of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not but Gustav Wex's Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequence is given in 129.4. Note 1. This standard specifies specific code point additions U plus 0024, $, and U plus 005F, low line, are permitted anywhere in an identifier name, and the code points U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2. 7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2. Identifier names that are canonically equivalent according to the Unicode standard and not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2. 7. 1. 1. Static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2. 7. 1. 2. Static semantics. Identifier code points. The syntax-directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions. Identifier name. Identifier start. Let CP be identifier code point of identifier start. Return CP. Identifier name. Identifier name. Identifier part. Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2. 7. 1. 3. Static semantics. Identifier code point. The syntax-directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise of the following productions. Identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the NV of code point. 2. 7. 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed-width font, in some syntactic production. The keywords of ECMAScript include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts if and while a reserved word's await is reserved only inside async functions and more. Without restriction, this specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names: those that are always allowed as identifiers, and are not keywords, such as math, window, toString, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield. Those that are contextually allowed as identifiers, namely await and yield. Those that are contextually disallowed as identifiers, in strict mode code. Let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax: reserved word. 1 of await break case catch class const continue debugger default delete 2 else enum export extends false finally for function of import and instancia of new null return super switch this throw true try type off var void well with a yield 24 ECMA International 2024 note 1 per 5 1 5 keywords in the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13, 1, 1, 8, 6, 4, 1, 5, 2, 1, 1, 5, 5, 1, 1, 5, 6, 1, and 1, 5, 8, 1. 2.8 Punctuators syntax. Punctuator, optional chaining punctuator. Other punctuator, optional chaining punctuator. Look ahead decimal digit. Other punctuator, 1 of, comma equals, equals 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 plus, percent plus plus, and equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. Div punctuator, equals sign. Right brace punctuator. 2.9 literals. 2, 9, 1 null literals syntax. Null literal, null. ECMA International 2024 225. 1, 2, 9. 2 Boolean literals syntax. Boolean literal, true, false. 2, 9. 3 numeric literals syntax. Numeric literal separator. Numeric literal, decimal literal. Decimal big integer literal non-decimal integer literal, plus sep. Non-decimal integer literal, plus sep. Begin literal suffix legacy octal integer literal. Decimal big integer literal. 0 big int literal suffix. Non-zero digit decimal digits, plus sep oct begin literal suffix. Non-zero digit numeric literal separator decimal digits, plus sep. Begin literal suffix. Non-decimal integer literal, sep. Binary integer literal sep. Octal integer literal sep. Hex integer literal sep. Begin literal suffix. n decimal literal decimal integer literal decimal digits plus sep opt exponent part plus sep opt decimal digits plus sep exponent part plus sep opt decimal integer literal exponent part plus sep opt decimal integer literal 0 non-zero digit numeric literal separator opt decimal digits plus sep non-octal decimal integer literal decimal digits sep decimal digit sep decimal digit plus sep decimal digits plus sep numeric literal separator decimal digit 1 of 0 1 2 3 4 5 6 7 8 9 26 ECMA International 2024 non-zero digit 1 of 123,456,789 exponent part sep exponent indicator signed integer sep exponent indicator 1 of EE signed integer sep decimal digits sep decimal digits sep decimal digits sep binary integer literal sep 0b binary digits sep 0b binary digits sep binary digits sep binary digit sep binary digit plus sep binary digits plus sep numeric literal separator binary digit 1 of 0 1 octal integer literal sep 0 octal digits sep 0 octal digits sep octal digits sep octal digit sep octal digit plus sep octal digits plus sep numeric literal separator octal digit legacy octal integer literal 0 octal digit legacy octal integer literal octal digit non-octal decimal integer literal 0 non-octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L non-octal digit non-octal decimal integer literal decimal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L 0 octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L octal digit 1 of 1,234,567 non-octal digit 1 of 89 ECMA International 2024 227 hex integer literal sep 0x hex digits sep 0x hex digits sep hex digits sep hex digit sep hex digit plus sep hex digits plus sep numeric literal separator hex digit 1 of 0 1 2 3 4 5 6 7 8 9 abdef a b c d e f. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2 9 3 1 static semantics early errors numeric literal legacy octal integer literal decimal integer literal non-octal decimal integer literal. It is a syntax error if the source text match by this production is strict mode code. Note to non-strict code. This syntax is legacy 2 9 3 2 static semantics MV. A numeric literal stands for a value of the number type or the big int type. The MV of decimal literal decimal integer literal decimal digits is the MV of decimal integer literal plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. excluding all occurrences of numeric literal separator, the envy of decimal literal, decimal integer literal. Exponent part is the envy of decimal integer literal. 10e, wary is the envy of exponent part, the envy of decimal literal, decimal integer literal. Decimal digits exponent part is the envy of decimal integer literal plus the envy of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the envy of exponent part, the envy of decimal literal. Decimal digits is the envy of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, the envy of decimal literal. Decimal digits exponent part is the envy of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the envy of exponent part, the envy of decimal literal. Decimal integer literal exponent part is the envy of decimal integer literal 10e, where e is the envy of exponent part, the envy of decimal integer literal. 0 is 0, the envy of decimal integer literal. Non-zero digit numeric literal separator decimal digits is the envy of non-zero digit 10n plus the envy of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, the envy of decimal digits. Decimal digit is the envy of decimal digits 10 plus the envy of decimal digit, the envy of decimal digits. Decimal digits numeric literal separator decimal digit is the envy of decimal digits 10 plus the envy of decimal digit, the envy of exponent part. Exponent indicator signed integer is the envy of signed integer, the envy of signed integer. Decimal digits is the negative of the envy of decimal digits, the envy of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0, the envy of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the envy of decimal digit. 2 or of non-zero digit, the envy of decimal digit. 3 or of non-zero digit, the envy of decimal digit. 4 or of non-zero digit, the envy of decimal digit. 5 or of non-zero digit, the envy of decimal digit. 6 or of non-zero digit, the envy of decimal digit. 7 or of non-zero digit, the envy of decimal digit. 8 or of non-zero digit, the envy of decimal digit. 9 or of non-zero digit or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the envy of hex digit, or of hex digit. A is 10, the envy of hex digit. B or of hex digit. B is 11, the envy of hex digit. C or of hex digit. C is 12, the envy of hex digit. D or of hex digit. D is 13, the envy of hex digit. E or of hex digit. E is 14, the envy of hex digit. F or of hex digit. F is 15, the envy of binary digits. Binary digit is the envy of binary digits 2 plus the envy of binary digit. The envy of binary digits. Binary digits numeric literal separator binary digit is the envy of binary digits plus the envy of binary digit. The envy of octal digits. Octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit, the MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit, the MV of non-octal decimal integer literal. Capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit is the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of non-octal digit, the MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit, the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit is the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of octal digit, the MV of hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit, the MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digits 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions. Numeric literal, decimal literal. Return round MV result, MV of decimal literal. Numeric literal, non-decimal integer literal. Return, MV of non-decimal integer literal. Numeric literal, legacy octal integer literal. Return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix. Return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit big int literal suffix 1. Return the big int value for the MV of non-zero digit. Decimal big integer literal, non-zero digit decimal digits big int literal suffix, non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let nv be the MV of non-zero digit 10n plus the MV of decimal digits. Return z, MV 2, 9. 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U+005C, reverse solidus, U+000D, carriage return, and U+000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMAScript string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as two code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator. ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence, 30, ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, x hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 1293. Source character is defined in 11.1, ECMA International 2024 231. Note 2, LF and CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2, 9, 4, 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the so-as text match by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2, 9, 4, to static semantics, SV. The syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1293. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, LS.
This is getting boring. Real boring.
Separator. The SV of double
super boring. I just want to get to code now. like benchmark and stuff.
Situation is the empty string, the SV of single string character,
So like,
but not one of or line terminator is the result of performing UTF-16 encode.
I have everything shuffled around. I deleted the things I'm not going to use, or like, not using now. I turned off some of the spots that were using other things. So I'm going to double check that nothing else is using these two kinds.
000 null. The SV of character escapes.
And then I simply have to make a macro that will expand these types, whatever. I don't know. The rest of it's simple. And when it comes to like printing, I think I might need to like keep things as like 3 separate rows.
8 string single character.
Like when it prints this, whatever.
Code unit value, Unicode character name, symbol B 0 times 0.
And like not go crazy with making a fancy log output. So I have like print to 3 separate strings for like the different times, and then I'm making a loop afterwards that grabs the whole chunk and then writes it, and then finds the width or whatever of the longest character or line, whatever, and then writes the next line of code instead of like adjusting this thing to count for width. So I don't know. I think I'll do that for this, for like that part, whatever. I have to figure out how to get it to log a file. Because this box, Windows box,
The SV of escape sequence.
this can only hold so much text. And it's really blurry. I don't want to look into the API and even mess with it. I just want to print stuff to a file. Because I can't copy this stuff either. Like it's just text in a window. I can't even like copy paste it. I don't know. Try to make the macros or whatever. This is so boring.
Escape sequence. X hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4. 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82. Times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4, the MV of 4 to 7. 5 is 5, the MV of 4 to 7. 6 is 6, the MV of 4 to 7. 7 is 7, the MV of hex escape sequence. X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit, plus 0 times 100 the MV of the second hex digit, plus 0 times 10 the MV of the third hex digit, plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input elements scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMAScript regular expression grammar. 2.2.2.1. An implementation may extend the ECMAScript regular expression grammar defined in 2.2.2.1. But it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, regular expression char, regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars. Empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate two regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. C22.2.4.34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char 2.9.5.1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expers, sign literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1 2 9 5 to static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1, 2, 9, 6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sopt. Note: 2 regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use Dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $, or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead not code point. Hex digits. SEP. But only if MV of hex digits. 0 times 10 FF. Code point. Hex digits. SEP. But only if MV of hex digits 0 times 10 FF. Note: template substitution tail is used by the input element template tail alternative lexical goal 1, 2, 9, 6. 1 static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters, template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of he TV of template character and the TV of template characters. The TV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $, is the string value consisting of the code unit 0 times 0024. $. The TV of template character, template escape sequences the SV of template escape sequence. The TV of template character, not escape sequence is undefined. The TV of template character, line terminator sequences the TRV of line terminator sequence. 236. Copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequences the empty string 1, 2, 9, 6. To static semantics. TRV. The syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $, is the empty string. The TRV of template middle, $, is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $, is the string value consisting of the code unit 0 times 0024. The TRV of template character, template escape sequence is the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence, the TRV of template character, not escape sequence is the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence, the TRV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit. The TRV of not escape sequence, X, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter x. The TRV of not escape sequence, X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter x, and the TRV of hex digit. The TRV of not escape sequence, U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter u. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit. The TRV of not escape sequence, U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the code unit 0 times 007b, left curly bracket. The TRV of not escape sequence, U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, and the TRV of not code point. The TRV of not escape sequence, U, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, and the TRV of code point. The TRV of decimal digit, 1 of 0 1 2 3 4 5 6 7 8 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence, non-escape character is the SV of non-escape character. The TRV of single escape character, 1 of BFNRTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence, X hex digit is the string concatenation of the code unit 0 times 0078, Latin small letter x, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence, U hex 4 digits is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex 4 digits. The TRV of Unicode escape sequence, U, code point, is the string concatenation of the code unit 0 times 0075. Latin small letter U. The code unit 0 times 007b. Left curly bracket. The TRV of ECMA International 2024 237. Code point. And the code unit 0 times 007d. Right curly bracket. The TRV of hex 4 digits. Hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit. The TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation. Line terminator sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of line terminator sequence. The TRV of line terminator sequence. LF. is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence. CR is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence. LS is the string value consisting of the code unit 0 times 2028 line separator. The TRV of line terminator sequence. PS is the string value consisting of the code unit 0 times 2029 paragraph separator. The TRV of line terminator sequence. CRLF is the string value consisting of the code unit 0 times 000 line feed. 2.10 automatic semicolon insertion. Most ECMAScript statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.10 rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of a do-while statement 147.2. When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, that the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence. 38. ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the 2 semicolons in the header of a for statement C147.4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression yield await. No line terminator here. Plus plus left-hand side expression yield await. No line terminator here. Continue statement. Yield. Await. Continue. Continue. No line terminator here. Label identifier yield await. Break statement. Yield. Await. Break. Break. No line terminator here. Label identifier yield await. Return statement. Yield. Await. Return. Return. No line terminator here. Expression. Plus in yield await. Throw statement. Yield. Await. Throw. No line terminator here. Expression. Plus in yield await. Yield expression. In. Await. Yield. Yield. No line terminator here. Assignment expression in. Plus yield await. Yield. No line terminator here. Assignment expression in. Plus yield await. Arrow function. In. Yield. Await. Arrow parameters yield await. No line terminator here. Equals. Concise body in. Async function declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Yield. Plus await. Async function body. Plus default. Async. No line terminator here. Function. Formal parameters. Yield. Plus await. Async function body. Async function expression. Async. No line terminator here. Function binding identifier. Yield. Plus await opt. Formal parameters. Yield. Plus await. Async function body. Async method. Yield. Await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Yield. Plus await. Async function body. Async generator declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Plus yield. Plus await. Async generator body. Plus default. Async. No line terminator here. Function. Formal parameters. Plus yield. Plus await. Async generator body. Async generator expression. Async. No line terminator here. Function binding identifier. Plus yield. Plus await opt. Formal parameters. Plus yield. Plus await. Async generator body. Async generator method. Yield. Await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Plus yield. Plus await. Async generator body. Async arrow function. In. Yield. Await. Async. No line terminator here. Async arrow binding identifier yield. No line terminator here. Equals. Async concise body in. Capital C. O. V. E. R. Capital C. A. L. L. Capital E. X. P. R. E. S. S. I. O. N. Capital A. N. D. Capital A. S. Y. N. C. Capital A. R. R. Yield await. No line terminator here. Equals. Async concise body in. ECMA International 2024 239. Async arrowhead. Async. No line terminator here. Arrow formal parameters. Yield. Plus await. The practical effect of these restricted productions is as follows. When a plus plus or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token, then a semicolon is automatically inserted before the plus plus or token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token.
The thing that really annoys me about this so-called position independent code is that you can do move, like RDI, REX, relative, label thing. That's fine, but you can't do move, relative, label thing, RAX. which means that if you have to store anything to a destination,
Expression should start on
it only can be a label. But you can move from a label.
as parameter.
I don't know. This is just stupid as fuck. The fact that you can mix relative addressing with absolute addressing. Once you store a relative address, it's automatically absolute. So like, this is just, I don't know. XD64 is fucking stupid.
A valid ECMAScript sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMAScript sentence. The source 4, A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source return a plus B is transformed by automatic semicolon insertion into the following return a plus B. The source a equals B plus plus C is transformed by automatic semicolon insertion into the following a equals B plus plus C. The source if a B else C equals D is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be passed as an empty statement. The source a equals B plus C D plus C print is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call a equals B plus C D plus C print. In the circumstance,
This is what I mean.
begin with a left parenthesis. It is a good idea
Is it ever possible
at the end of the preceding
the operand, the destination, to have relative in it? Short answer, no, not directly. For instructions that write to memory.
as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2: the token plus plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus plus. ECMA International 2024.
Okay, let's see. Instruction form. Move, register, symbol. Move, register, symbol. This is supported, but this isn't. And then they hide it by the fact that you make it default relative. That's why they use default relative. Because you can't write to memory in a way that is RIP, relative, which means none of this shit is fucking position independent. Nothing. If all of the rights are not relative, if only the reads, all the rights, the program, even though they don't change it, it's all based on assumption. If it changed, you're fucked. The code's fucked. This whole thing is fucking dumb and it pisses me off. It's just so stupid. And then they hide it by making default absolute. First off, they get rid of the segment registers. There's no more code segment, no more data segment, you have no control. But then they have all this freaking RIP shit. And then like, fucking hide it. And it's like really confusing to figure out. So, I'm gonna ask chatbot, if this is true, it means that behind the scenes, any move, symbol, register is absolute. Yes or no? I'm gonna chat about that. And then I'll like have my answer, because I think I've kind of figured it all out. This is just stupid as fuck. The code does not. That's why the code, the program, doesn't change when it starts. Because the CPU can't even support writes, which means that the whole program would have to have like a pause or something. So if it ever had to be moved, the program would pause and then it would move it. Except your code would have to know beforehand so it could like recompute anything that was moved. It's not position independent. It's just fucking stupid.
Operands and no line terminated.
And it's so annoying. So I changed it to default absolute. Because if I get angry and annoyed and pissed off, I have more energy to keep going. This stuff is fucking stupid.
International 2024, 13 ECMAScript language. Expressions 3.1 identifiers syntax, identifier reference, yield, await, identifier, yield, yield, await, await, binding identifier, yield, await, identifier, yield, await, label identifier, yield, await, identifier, yield, yield, await, await, identifier, identifier name but not reserved word. 3. 1. 1 static semantics, early errors, binding identifier, identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference, yield binding identifier, yield label identifier, yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference, await binding identifier, await label identifier, await. It is a syntax error if the goal symbol of the syntactic grammar is module.
So now I'm asking chatbot, is it true that move, relative symbol, register is not possible? And using default, relative hides this fact. Yes or no?
3. Yield and await are permitted as binding identifier in the grammar, and prohibited with static. Note, semantic.
It says yes, it's true that move, relative symbol, is not possible. The CPU instruction does not support direct writes to RIP, so you can only read from RIP. You can't have RIP writes. Regarding default relative, no, it does not hide this fact. Yes, it does. It means you don't have to write relative, which means that every single write, if you use a label and you don't know about it, you're never going to have to write relative for anything, which means you don't know that move relative label isn't valid and move relative register is never valid. Freaking, there's only a move with the right hand side ever being fucking relative. This is just stupid. It's so dumb. So fucking stupid. 64-bit processors have been out for like 22 years or something. And they don't have relative moves as a destination. Like, are you fucking kidding? It's fucking stupid. They make so much money off selling shit, for fuck's sake. This is bullshit and stupid. I don't know. This is so annoying.
Code point.
You can't call it something. It's like calling fat people skinny. No, you're fat or you're not. There's a bunch of other examples. I really don't care about pissing anyone off. Because I have to fucking write with this shit. Like, what the fuck even is a CPU? It's a joke. This instruction set sucks ass. And the butt too, just all of it.
Identify name, module export name.
It's so annoying. It's like, you want to keep your code position independent. And it's like none of it is technically the only way to write position independent code that's truly position independent is to never write back to memory. You could only ever read. So you're limited to the 16 registers. You can never do any writes. That's the only way a program would ever be position independent, because all and every single write becomes absolute. Okay, I'm done. I'm gonna keep going. Freaking, I hate this shit.
Expression, yield, await. This identifier reference yield await. Literal, array literal yield await. Object literal yield await. Function expression, class expression yield await. Generator expression, async function expression, async generator expression, regular expression literal, template literal yield await. Tagged, capital C O V.
And it's annoying because behind the scenes, clearly, where it says here, they're like, if you want to do a position independent code that's REP relative, do this. No, it's the fact that RDI is absolute means it's not position independent anymore. Behind the scenes, this is clearly what's going on behind a couple instructions. Just because it doesn't show up in the code doesn't mean that's not what's going on. It's clearly, this is just stupid. 64-bit is a joke. This is just dumb. They shouldn't have hacked up the 32-bit instruction set and faked 64-bit. 32-bit was fake. It was easier to hide. But 64-bit is like super fake. Like really, really fake.
Expression, plus in yield await. Binding identifier yield await. Expression, plus in yield await. Binding pattern yield await. Note 2 in non-strict code. The keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can...
So I'm like trying to carefully update this to use position absolute at the top. I'm carefully going to try to update every place it accesses an address and rename it to relative or leave it because it'll be absolute now. And I think I gotta end this stream, so like I'm gonna go on a little bit longer. I wanna get something done. So I'm gonna put like the BRB screen. In a minute. So I don't know. I'll put BRB. I'll just say this again in a minute.
Capital E X P.
It doesn't matter, I'll just do it now. So I'm gonna let the stream run on for like 10 more minutes, because it doesn't always end. And I'll like start another stream after this, whatever they finish up some stuff. So I don't know, I'll BRB the stream.
Keyword 3, 2, 1. 1 runtime semantics. Evaluation. Primary expression. This. Return. Resolve this binding. 3, 2. 2 identifier reference. C13.1 for identifier reference 1 3, 2. 3 literals. Syntax. Literal. Null literal. Boolean literal. Numeric literal. String literal. 2, 3. 1 runtime semantics. Evaluation. Literal. Null literal 1. Return null. Literal. Boolean literal. If Boolean literal is the token false, return false. If Boolean literal is the token true, return true. Literal. Numeric literal. Return the numeric value of numeric literal as defined in 1 2 9 3. Literal. String literal. Return the SV of string literal as defined in 1 2 9 4 2 46. ECMA International 2024 1 3 2 For array initializer, array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax: array literal, yield, await, elision ort, element list yield await, element list yield await, elision ort, element list, yield, await, elision ort assignment expression, plus in yield await, elision ort spread element yield await, element list yield await, elision ort assignment expression, plus in yield await, element list yield await, elision ort spread element yield await, elision, spread element, yield, await, dot, assignment expression, plus in yield await, 1 3, 2, 4, 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision: let len be next index plus 1. Perform. Set array length len true. Note: the above step throws if len exceeds 232. 1. Return len. Elision return array accumulation of elision with arguments array and next index plus 1. Element list elision ort assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x. Init value. Return next index plus 1. Note: an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list elision ort spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return array accumulation of spread element with arguments array and next index. Element list elision ort assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x. Init value. Return next index plus